All right, everyone, welcome back to Ask a Scientist Gaming, combine mediocre gameplay with expert level science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry. I do all things light matter interactions, photons driving chemical processes, or solar cells, or whatever it might be. Joining me today is Dr. Ryan Baumbach. Ryan, if you wouldn't mind introducing yourself.
Thanks. Hi to everyone. My name is Ryan Baumbach. I'm a research faculty at the National High Magnetic Field Laboratory, where our group is especially interested in synthesis of novel crystalline materials that can have behaviors where electrons can do things that they don't normally do. So, for example, we like to make new types of superconductors, new types of magnets, materials with unusual topological states, so on and so forth. And we're really focused on producing these materials from scratch. So we're kind of like, I don't know, science bakers or something like that. We like to make things hot. We like to drive chemical reactions and see what we get.
Yeah, it's glorified cooking.
It's glorified cooking.
All right. Equally important, what game are we playing today?
Well, this is an old favorite of mine. I've actually been trying to get it on any gaming system for a long time, so this is a real pleasure. We're going to be playing Symphony of the Night, Castlvania, and I'm really looking forward to it. I haven't played this since college, which was a long time ago. so this is going to be great.
For PlayStation.
Oh, yeah.
Believe it or not, this is one of the more advanced systems we play on.
Yeah.
A lot of retro.
Oh, I mean, look at this. How can you not love this?
Yeah,
this is incredible.
Beautiful.
Yeah.
Konami, too.
Konami. That's how you know it's quality.
Does the Konami code work on this? Do you remember the Konami code?
I do. Who could forget it? I mean, there's a certain generation that has that, permanently embedded in their brain.
All right, I'm going to skip you ahead so you don't have to do any of that.
Let's take a journey back to 1792.
Classic.
Ancient history.
Yeah.
Wow. Look at this. Does anyone recognize this map? Is it water or land?
I need to have a cartographer on. That's what I need.
That's a great idea. I mean, what a good idea. Look at this. It's creepy. I mean, you've got steam rising off of the lake or fog or something. Castle is perched on the edge.
32
Wow.
qubits. Thank you for the follow and the first time chat to notify us we didn't have sound. I apologize for that.
Much appreciated.
I have 6 different mute buttons on this setup, and you pointed out I left one of them on. So take 2, we got it right. Reese's Pieces, welcome back. Bronco, it's good to see you. Hopefully finals went well. End of the semester, last stream of the semester. Everyone welcome. We're going to chill out and drink some beer and talk some science.
Excellent.
So I'll let you settle in a little bit before I start dropping questions on you.
Sure.
We got some ambiance from the gameplay.
Yeah. One of my favorite parts about this game is when you get halfway through, the castle turns upside down.
USB Mark, thank you for the follow. Enjoy your standard internet units. They don't do anything outside this channel, but you can unlock emotes. You can bet on questions, which we will bring forward in a little bit. In particular tonight, our guest is Dr. Ryan Baumbach, going to talk about magnetism. I use the word exotic materials.
I like it.
Okay.
I like it.
I think that, especially the topological stuff and quantum, and
absolutely.
I think it's a fair
And these
descriptor.
days, we should call them quantum materials.
I like it.
You don't belong in this world.
Aw,
It was
that's so
not
sad.
by my hand that I'm once again given flesh.
Yeah, Dracula is really just cursed, right? That was
Like you said, it's not his fault.
yeah,
You know.
it's just
Tribute.
where he ended up.
It's just the way things went for him.
Make them your slaves.
Mm.
Perhaps the state will be
It's a good point, Richter.
Your words are
I'll let the audio go before opening questions or dumping questions on you.
Sure.
Such as you.
What is a man?
It's a good question.
A miserable little pile of secrets. But enough.
This is a great quote. What is a man but a miserable little pile of secrets? That's deep, Dracula.
Nailed it.
Yeah.
All right, you're fighting a boss.
All right,
I don't
here
think
we
you can die during this fight.
Nope.
So I think it's fair game.
Absolutely.
All right, let's start with the fundamental one. Calm down, Bronco. What gives materials magnetic properties?
Oh boy. So basically, well, that's a complicated question, but it's fundamentally it's quantum mechanical spin, right? So if we want to, I should say, quantum mechanical angular momentum, right? So if you think about a spinning bicycle tire, for example, it has angular momentum. And you know that because if you spin a bicycle tire, it's hard to turn it, right? You try to turn it and it resists you. That means it has a vector that's pointing out of the circle, right? That's not just the spinning tire, it's something else entirely. So that's your classical angular momentum. Turns out there's a quantum mechanical version of that too, and that is spin, really. And so what it comes from is the fact that matter has electrons in it. And those electrons carry, oh boy, what's happening here? Okay, so those electrons have a quantum mechanical property that is the spin. And it basically is one of the fundamental attributes of what electrons do and what they are. Now, the thing that's important to know about in practical terms is that even though all electrons, could have spin and they could be magnetic, electrons do a lot of weird things. And in a lot of elements, they kind of lose track of that characteristic of them. So when electrons are in a material and they can kind of spread out and form bands, they don't really retain that magnetism or spin character anymore. And that's why you see that, if you think about most elements, they're not exactly magnetic, but something like iron, or if you remember all those elements at the bottom of the periodic table, the lanthanides, the way that those electrons are distributed around the nucleus makes it so that they are well defined in space. They have a well-defined wave function, and as a result, their angular momentum quantum numbers are well defined, right? And so you really only get good local moment magnetism out of certain parts of the periodic table. Okay, that's a really hand-wavy explanation for why.
No, it's a hard question.
It is a hard question.
All electrons have spin.
I mean,
sometimes that spin cancels, and then you're not magnetic.
That's right. I guess that the Insane Clown Posse put it best.
Yeah.
What is
magnets?
magnetism?
Magnets, how do they work? in song form. Related question, 32 Qubits wants to know, is it true that the Maglab maintains the Earth magnetic field?
Absolutely, and that's why the NSF should keep sending us money.
Did you hear that, NSF?
But no, really, no. We also don't control the weather either.
What does cause the Earth's magnetic field?
Good question. So as far as I understand, and I've never been there, but the center of the Earth is liquid, right? It's a molten metal core, and it's spinning. And I guess the reason it's spinning is because angular momentum is conserved in the universe.
I'll skip you ahead.
Thank you.
We'll skip over the...
And it helps that it's liquid for it to spin. And anytime you've got electrons that are, taking a path around and around and around, that generates a magnetic field that runs perpendicular to it. So, not all giant planetoid sorts of things in the universe have liquid cores. And as a result, not all of them have a magnetic field coming out of them. And actually, life on Earth is, pretty dependent on the fact that we have that. So we're, sort of in a really special situation to have a molten core that spins and produces a magnetic field. What it does for us is it deflects, charged particles that are shooting at us from the sun that would otherwise kill us all. So it's pretty important.
We like it. Life on Earth is pretty dependent on the Maglab. Got it. That's all they heard.
That's all you need to know.
That's fun.
Oh yeah, fish people.
Man. Unrelated. On this channel, for some reason, we end up killing a lot of dogs and wolves. So, between this and NARC. Sorry, dog lovers. It's just a coincidence of the game, so we have nothing to do with it.
These are evil wolves.
Yeah, no, that's justified.
Yeah.
And the other ones are drug wolves, so...
They're drug wolves.
dogs.
Everyone knows
So-
drug dogs are evil. Yeah.
Oh, man.
Ooh, money. All right.
So is it coming back to you, or you're feeling it?
Yeah, I'm feeling it. I mean, for sure. Look at this. This Grim Reaper, such a pain in the butt.
All right, USB Mark following up on the first answer. Explain for us supermagnetic materials.
Oh.
Yeah, there's magnetic materials, and then there's supermagnetic materials.
Well, I mean, okay. So I think a term like supermagnetic might have several different meanings. So let me take a stab at it, and I'm not 100% sure that it's going to be the right answer. But that guy just took all my stuff. You see that? Okay, so now I have to fight with just fists. Okay, supermagnetic. So let me just try to see if I can figure out what this means. So, I mean, if we say that something's magnetic, it probably means that it's some sort of conventional magnetism. Oh, and one thing I'd like to mention, you know, I've been talking about permanent magnets, more or less.
Yeah.
But don't forget that you can make a magnetic field just by moving electrons, right? So I think people have probably made solenoids and wrapped them around a magnetic core and, you know, done that sort of thing. But so I'm going to talk about permanent magnets right now. So what would make it a super magnet? Well, probably what it means is short sword. Let's make something that somehow has an enhanced permanent field. I think that's probably along the lines of what we're talking about. Let me equip this. I'm not capable of doing two things at once.
No worries. Take your time.
Okay.
We have 3 hours. We have plenty of time.
So if we want to make a super magnetic field, like on a permanent magnet, we want to somehow get that thing to be putting out more flux lines of a magnetic field. This is probably worth talking about too. So what is a flux line, right? What even is a magnetic field? I actually had to look this up with my daughter the other day for her middle school science class.
They asked that you didn't know. That's amazing.
Well, the definition is really esoteric in some sense, or it can be extremely mathematical, and that's not a very useful definition. But the definition that you'll find online is that it's an energy field that's composed of a magnetic component and an electrical component, and they're perpendicular to each other. Kind of getting a little bit far afield of what you're asking, but okay. So
no, keep going.
But if you have a static field, if you have a static field that's coming out of a permanent magnet, it doesn't have that electrical field part. It just has the magnetic field part. And so now we want to make it really strong, if possible. So one way that you could think about doing that is to cram a material full of spins, right? Of these localized electrons that we were talking about. And some elements are especially good for that. And of course, if you want to cram a bunch of them into a material, you need to have a lot of sites where they could go in that material, right? So now you got to think about a crystalline structure maybe. And a crystalline structure just means a regularly repeating pattern of ions, one after another. So maybe the best thing to do would be to have something that's really super close packed, and then have all of those close packed atoms be filled by magnetic spins, right? That would be fine. And if you could do that with the right type of element...
I think you just picked up a shield.
Oh,
yeah.
Let's see about that.
Let's upgrade.
Let's see about that. Oh, leather shield. All right. Excellent.
That'll help against Dracula.
So I would say if you could pack a material really full of spins that have a large intrinsic magnetic moment, like lanthanides. So a lanthanide might be neodymium or gadolinium. That would be, super magnetic. Okay, that's one thing. But let me tell you about something else that maybe is more interesting. I mean, not that that's not interesting, because that's basically what I do for my career.
No, it's subjective, to each his own.
It's interesting, I promise. But, resist thunder. All right. So there are different ways to make magnetic fields. And remember I said you can get a current moving, and you can, it's moving, or even a straight line. It's producing a magnetic field. So a special environment where you can make currents go and have them not stop is a superconductor, right? So if you maybe I should say what a superconductor is. Although that's one of our questions.
Yeah.
Let me start just by saying that a superconductor has the property that electrical currents can flow in it without dissipating any energy. All right? So you could imagine you could have a material like that where you get that current moving, and then it generates a magnetic field that's coming out of it. And then you've got a permanent magnet that's really different from the permanent rare earth magnets. It's taking advantage of a completely different state of matter, which is a really special state of matter. And it turns out that if you do that, in just the right way, you can get those electrons moving, you can trap flux inside of that superconductor, and you can generate really big magnetic fields that are permanent fields coming out of that superconducting puck or whatever. And I'm not sure, but I think that might be what the question was actually sort of trying to get us to go for.
So permanent is an interesting word.
Yeah.
'Cause nothing's permanent, right?
Yeah.
Even standard permanent magnets. It's a question of how long they last. And
that's a good, so that's a good question. I mean,
like even iron will lose its field, right, over time.
That it will.
But it takes a long time, right?
It takes a long time. So, let me talk about that a little bit. That's fun.
All right.
So the spin...
Before you do, Reese's Pieces is calling you out. They said, what do you mean math is perfectly precise and concrete?
No, I don't. I definitely know.
Don't start that fight. The math definition is right.
So, okay, what is permanent? The spin, if I had a piece of gadolinium, a single atom of gadolinium, the spin that's sitting on that is nearly permanent.
Well, that's
right. Like that's really not going anywhere.
Depends the lifetime of
the gadolinium,
right?
Yeah.
What's the half-life of gadolinium?
Yeah. So that's the caveat. Like if the gadolinium is going to go through nuclear decay, then it's not permanent. But it's many times the lifetime of the universe. I don't really know. But in that sense, it's nearly permanent. But then that's not really what we really deal with on a regular basis.
Yeah.
And so what we're really dealing with are ensembles or collections of spins in a solid. And so now you've got these spins that are sitting on different...
This is a teamwork boss here?
Yeah,
what is this?
Look at these guys.
I don't know.
This is really inspiring, actually. Even monsters can
work together accomplish a goal.
And actually, if you really think about it, I mean, what business does this guy, Alucard or whatever his name is, have in coming here and disrupting their happy home?
No. This is very I Am Legend, right?
Yeah, what's he doing here?
I Am Legend, the book, not the Will Smith movie.
You really can't blame these guys for...
defending their home, their kids.
Really.
Their well-being.
Really. If someone showed up in my house and started hitting me with a sword, Oh, no. See? Oh, they were right.
Yeah, no, they earned that.
Yeah, they earned that.
For disrespecting their property. All right. Questions. Reese's Pieces, you mentioned interesting topological properties. What kind of topological? So this is not topological map type properties. This is abstract.
Let me try to... Should I finish the magnets thing? Or
yeah, you can finish the magnet thing.
Okay, let me just finish the magnet thing and say that when we're talking about collections of spins...
Oh, it started you over?
Oh, well.
We could try to create a save state. I don't know.
Maybe I should have saved it. Yeah. Maybe that's the trick.
Yeah.
Well, we can move on to another game eventually, too.
Yeah.
People will get tired of seeing me kill dogs.
Evil dogs.
Evil dogs. So once you get all these spins together, now they're in a solid, and they're, pointing whatever way you want. But what you can do is you can get them to all line up. If you, apply a magnetic field to them, maybe you can get them to all line up. But over time, it may be through different reasons that they start to demagnetize, right? They may start to point in different directions, and then the net moment of the object, whatever it is, will become non-magnetic, even though the individual spins are still, they're little tiny magnets, but
Yeah.
the big thing is not magnetic anymore.
Well, what's fun is you can do this yourself. Like you can take a permanent magnet and take like a paper clip and just rub it against it over and over again the same direction, and it'll make that paper clip temporarily magnetic. And it'll lose that
Very cool.
relatively quickly. And it's
very cool.
because the alignment and the strength of it and how well it maintains that, and the, you know, Boltzmann, all sorts of things screw that up.
That
Yeah.
actually reminds me of one other thing too that's not about magnetism, but have
Yeah.
you ever taken you know, you can take like a, I don't know, a rabbit's paw, you know, to put static electricity on something.
Yeah.
And then get a laminar flow of water coming out of the sink,
Yeah.
right? And then bring the paw, you know, close to it,
Yeah.
and it deflects the water.
Flex water.
It's really cool.
What's driving that? Is that
I think it's just static electricity.
just field based?
Yeah,
That's pretty fun.
yeah, that's pretty cool. That's a cool one.
All right, so back to Reese's Pieces question. You mentioned
Okay.
interesting topological properties. What
Yes.
kind of topological
Yes.
properties? What
Okay,
does that mean in this
so
context?
this is a tricky topic that has only emerged as being a big part of condensed matter physics in the last 10-ish years. In fact, when I was a graduate student, nobody talked about topological electronic properties. It wasn't a thing.
Yeah, it was theorized, right?
It was
for some
theorized,
time,
but it would
not-
be like a weird mathematician thing.
Yeah,
right?
yeah.
And so what people talk about now is like this new field of topology is kind of a new chapter for the book of electronic physics. Okay, so what does it mean? Well, the idea of topology is a pretty mathematical concept, and the idea is that there's certain objects that you can deform into other objects. So, you know, a sphere, for example, can be deformed into a square, or, you know, other sorts of three-dimensional objects. And there's a certain, you know, integral over the surface that gives you a topological number. And I'm not a mathematician, so I don't really know how to do all that. But the point is that there's a different topology if you think about something like a donut or a coffee mug, right? Because they have a hole in it. Okay, so that's mathematical topology. It turns out that other quantities in nature have similar types of topological properties where you can kind of deform them into each other. And when they do have these properties, you know, most objects have what you would call like a trivial topology, but some of them don't, it turns out. And it turns out that sometimes you can get electrons to have non-trivial topologies. And that's a really vague way of sort of trying to summarize a lot of different things.
But it's a hard topic.
It's a hard topic, but a good way to think about topology, that at least that I can grasp, is that, you know, if you put electrons in a solid, they kind of all just go tearing around wherever, and they don't really remember where they've been, where they're going. They kind of lose their identity. But in some topological materials, they start to have constraints on them that make them behave as though they know a little bit more about themselves, in a way. And what I like to think about is that you have a thing that's called spin locking, where if they're traveling in one direction, their spin gets locked in one direction, and if they're traveling in the other direction, their spin gets locked in the other direction. And this is kind of like cars on the freeway, right? Like, cars could just go tearing around wherever they want and smash into each other and whatever. But they don't, because we've agreed that if you're on the right-hand side in the US, you go one way. If you're on the left-hand side, you go the other way. And that's kind of what electrons are doing. And the special property of what topological electrons are doing, and the special thing about this now, is that when they're spin locked, they're forced to go this way. And so it, at least in principle, reduces the importance of disorder effects that they encounter. So it's like they could travel and not scatter as they go. And so one thing that you would expect to see in these sorts of materials is that they would have extremely, they would be extremely insensitive to disorder scattering, or in other words, electrons could move really freely. This has implications for what the electronic band structure looks like. There's something called a Dirac Cone. Let's not worry about what that means.
Yeah.
But just means that they could move very, I don't want to say freely, but very coherently, in certain directions. And you can imagine that could be pretty useful. For example, if you want to transmit electrons from one point to another and not have the thing heat up, right? If they're not going to scatter, in a toaster, it heats up like crazy because it has all sorts of disorder scattering and they're dumping their energy as thermal energy. But in a, topologically protected Dirac metal, they can just go, they don't dump any energy. And so it's like a high conductivity sort of situation. It's also thought that this will be extremely useful for quantum computing. And I think I probably can't explain why.
No, that's fine. Keep playing. We'll keep it casual.
But quantum computing is extremely important. And many people believe that in the next couple decades, if anyone can make it work, that it's going to revolutionize many things about how society works.
So Reese's Pieces had the same donut and coffee mug analogy.
Good analogy.
Topology. No, it's really good. I've seen it. There's a few really good YouTube videos that explain.
There's
topology.
One other that maybe I can show here. So I'll just put this as a question. If I hold my thumb out and I don't turn my wrist, how can I go from being like this to being like this? Is there a way to do that? So I want to just leave that to see if anyone can sort that out. And then I'll show you in a little bit. Because there is a way to do it. And it's, again, because I'm not a mathematician, I don't understand the math, but there's a mathematical way to represent how that can be done.
So USB Mark has a guess already.
Okay. Maybe I should just show.
Yep.
Okay. So if you hold your arm out, let me see if I can do it properly. And go to the side, and then go up and come back down. I've turned my thumb.
Yeah.
Right? And that has to do with the topology of how I made that movement. So that's pretty cool.
Fun.
I would have never thought of that myself, but I saw it at a seminar once and was
That was them explaining it.
sufficiently impressed.
That's awesome. That's a really straightforward analogy. I like it.
All right,
All right.
skeletons.
Equally important, the question of the night. What are we drinking?
Ah, yes. Quite important. What do we have here? We have the frost-proof Belgian-style Cigar City. It's quite delicious.
Why did it go Founders IPA? Anyway. I don't know. My old Nightbot is working. I'll have to clean that up. Scuzzbot Wotus redeemed Take a Drink. Scuzzbot, thank you for swinging by. Thank you for redeeming Take a Drink. Ryan, cheers.
Cheers.
Welcome to the stream. Ask a Scientist Gaming. Mediocre gameplay expert, level science plus drinking alcohol. It's a good night.
Cheers. All right, here we go.
Orange juice, and that's why you go to seminar.
That's
kids.
right.
No, it is.
Oh.
Like seminars, you will retain like 5% of what you see at a seminar, but if it's an important 5%, that's awesome.
Yeah, I hate to say this, but for me, when I go to seminars, it's really about the first 5 to 10 minutes.
Yeah.
Right? Because that's when they offer the things that just anyone can grab a hold of.
Yep.
And unless, seminars can be pretty technical.
Yeah, and they can get technical quickly.
Yeah. So,
Like, and everyone should remember that when you guys are presenting, like, take your audience on a journey with you. Don't expect them to take every step the way you do, but like, the more you can bring them with you, the better the seminar is.
Yep.
Even if you don't get to show how smart you are or whatever, just like, people like a good presentation more than just word vomit and results.
absolutely.
So-
Absolutely.
And that is why you go to seminar, kids. If nothing else, you can demonstrate topology by playing Castlevania while drinking alcohol on Twitch stream on a Wednesday night.
And the other thing I would say is that when you're a scientist, you really get in your head. I spend a lot of time really very focused on the things that I'm obsessed with. But it's definitely the case that when I go, to a conference or to a seminar, then I get to generate some new ideas. And I start to feel. Sometimes when you're doing the work that you've chosen to do, you're actually pretty frustrated because it's not working right. But then when you go to a seminar, you can kind of get newly inspired.
Yeah.
Get a new
Well,
excitement.
It's very easy to get tunnel vision, like
So
just
easy.
focused on your stuff. And
So easy.
yeah.
It's like every day.
Reese's Pieces. An old professor of mine once said, at the beginning of seminar, everyone should understand. By the end, no one should understand.
Pretty much right.
I'm going to add a caveat to that. A really good presentation, at the start, everyone understands. At the end, everyone feels like they understand, but no one actually does.
Yeah.
Like they've been entertained by the movie, and they think they could direct one themselves. But alas, they do not have that knowledge set.
Absolutely.
Faithful Fairy. About 1/3 of the mandatory seminars my department asks everyone to go every Monday I went to, I'd start to feel dizzy about 10 minutes in. Yeah. It's tough. Like,
Well, and I want to add that when I was a graduate student, these guys. When I was a graduate student, I would go to seminar and feel just pretty much overwhelmed every seminar.
yep.
That's not unusual. I
Yeah.
think. You shouldn't feel like you're doing something wrong. Oh man, I don't know what to do about these guys. That's pretty. I'm gonna run away. Ugh.
Oh, speed strat. The jump across. I like it.
Yeah, I think that when you're a student, it seems like people who are in the business are really, I don't know, getting it all, and it's not so hard for them. That's just not true.
Yeah.
At least for experimentalists. I don't know how it is to
Ultimately,
be a theorist.
most of the time, even for someone in our field, we try to come up with one good question that's semi not stupid.
Mm-hmm.
Like, we try to understand it well enough to ask good questions.
I still often feel nervous when I'm at a seminar and I
yeah.
want to ask a question.
Yeah.
Yeah, for sure.
Especially when it's something you don't know. Like, we're interviewing people for biochem position right now, and it's like,
man.
I don't
Oh man.
I don't speak the language, I don't understand the words. But is that an axe? That's awesome.
Yeah, check it out. Here we go. Oh yeah. I can't go there yet.
Nice.
I'm remembering now how this game is such a maze. You know, you gotta like figure out all these different. Yeah, I played this way too much.
No worries. Oh, look at that.
Oh yeah, level up. Great.
So is there a save? Can you do a save? Is that
So
a thing?
did you see that room that had the
orb thing?
the orb thing?
Yeah,
that's
that's a save room. Okay.
Yeah.
So you have to hit one of those.
Yeah.
Okay. And it saves every time you go to it.
I'm pretty sure that what I have to do now is kill those two guys.
Yeah. No, it's time. You got your throwing axe.
All right, we'll give it a try.
But while you're doing that, let's do a prediction. It's
Okay.
time to spend some standard internet units, ladies and gentlemen. All right, which one do you want to do?
Well,
We kind of did that one.
let's see if we want.
All right.
That's a favorite in the field.
We are talking about superconductors. Ladies and gentlemen, if you're not following, click the follow button, get your 300 standard internet units, and you can bet them on this question that's coming up and win points that are useless everywhere else in the world except here. Nonetheless, it is fun to gamble on your scientific knowledge. Remember, you're on Ask a Scientist Gaming Honor Code, where you cannot cheat, you cannot Google answers. Instead, do the prediction on your own, based on your knowledge. So the question is a superconductor equal to a perfect conductor? And this is a hypothetical perfect conductor.
Right.
Is that right?
Hypothetical, because it'd probably be impossible to make a perfect conductor.
Yeah. But does it approach the theoretical limits of perfect conductor? The answer, true or false? Superconductor equals perfect conductor, true or false?
Ooh, 50-50.
Two people in, we're splitting the bet. All right, I'm getting another drink. Are you good or you need more?
I'm good for now. If I drink too many beers, I won't be able to answer any science question. Oh, I get it. Look at this. I got to get that skeleton to die on top of the switch. That's what I got to do. There we go. How am I gonna do
All
this?
right, ladies and gentlemen, spend your standard internet units. You can bet the default's 10, or you can do more. If you're curious about that, you don't know what I'm talking about. If you look at the chat, at the top of the chat, there's something you can click that says predict, and you can actually bet your standard internet units on the question. And the question is a superconductor equal to a hypothetical perfect conductor? Is that true or is that false? Use your standard internet units that you can use to unlock emotes. You can use it to make us drink. You can request a factoid. Now is your chance to bet and win some of that sweet, sweet imaginary internet points. It's actually clever. This is a recent addition from Twitch. It's like the last, I don't know, 9 months or so they introduced this.
Cool.
So it's not gambling because it's only predictions, but but it's kind of fun, and we use it for science questions. So
I like it. It seems like a good use of the function.
exactly. Make people do homework on their Wednesday nights off after the end of the semester.
Yeah. See, this game, what I like about this game is how realistic it is. See how that guy dies? Wow. And then he catches on fire.
That's an exotic material. I like it.
Yeah, you know,
All right.
if we had materials like that, we'd be real happy.
Does a superconductor equal a hypothetical perfect conductor? Is that true or is that false?
It's false.
False. Why is that?
Yeah, so it was a trick question. And
Well, we don't do trick questions on this channel.
so the reason is, I guess there's a whole bunch of different ways to try and answer this, but the most straightforward way to say it is that a superconductor has one additional property that a perfect conductor doesn't, and that is that it expels magnetic fields. So it has something called a Meissner Effect. And that's a special thing where when it enters the superconducting state, which it does through a phase transition, like magnetic order or something like that, when it enters the superconducting state, any magnetic field that's inside of it has got to get out, right? And that has to do with the fact that when it does that, it's entering a new quantum state for electrons. So in a metal, you know, you've just got electrons moving around, forming bands, doing whatever they do. And in a perfect conductor, that would mean it's that, but there's just no disorder scattering, which means they're not bouncing off of, you know, bad parts of the lattice or whatever. But in a superconductor, what's actually happened is that the conduction electrons have paired up. So they're doing a special type of dance. You know, normally electrons, because they're the same charge, they got to get away from each other. But when they're in a solid, they're also interacting with the lattice. The lattice provides a little bit of a attractive potential. And when you get to a low enough energy, low enough temperature, that attractive energy is enough to make them link up and form a new quantum state called a Cooper pair. And when that happens, it forms a new quantum state of matter that's completely distinct from any other sort of conductor. So it's not a perfect conductor. It's a superconductor.
So that's intrinsic to the definition of
It is.
superconductor. It has to dissipate that field.
Yeah. And I want to say something else about this. You know,
So it's not a trick question.
it's a true question.
But by the formal definition, it has to be true.
Yeah.
That's pretty fun.
And something I find so interesting, again, about condensed matter physics is that, okay, prior to the discovery of superconductors, which was I shouldn't say. It's one of our questions. I'll just say, prior to the discovery of superconductors, no one would have ever even guessed that electrons could do that. And at that point in time, you know, they were cooling down metals and trying to see what was going to happen. And some people thought that they would become perfect insulators. You know, if you stop all the electrons because they're too cold,
Yeah, they can't
it's
move.
an insulator.
Yeah.
And just through experimental efforts, there was no theoretical prediction. They discovered this new state of matter. And the story goes that when it was discovered, the lead PI didn't believe it was true. And he said, no, go back and do the experiment. You've messed something up. Okay, so point is that by putting electrons under new physical conditions,
You are hurting.
yeah, okay. You know, by cooling them down so much, they found something that was, cloth tunic. You know, never ever predicted before. And my opinion is that there's probably still states of matter, you know, in solids that we just don't know about yet. And they're going to have weird, you know, properties.
Yeah. I mean, it's pretty much guaranteed.
I think it's guaranteed. And, you know, people say, well, why do you need a Maglab? Why do you need to go to really high magnetic fields? Well, maybe it's analogous. You know, maybe if you can go to really high magnetic fields, you can find something new, or maybe other conditions are the ones you need. I don't know. But you can only find out by looking. So.
All right, do you want to see how that turned out? So it was 2-3 voting-wise, but the people that said false were very confident and bet 410. So not a huge payout.
Okay.
If it would have been true, it was a 21-1 payout.
Ooh.
So it's fun for us to see the outcomes of these questions because we have no idea ahead of time how these are going to turn out. So congratulations for those of you that picked false. Again, a superconductor does not equal a hypothetical perfect conductor. It has to dissipate field by definition of a superconductor, which is kind of fun.
Excellent.
All right. Catching up on a few questions from a while back. Calm Down Bronco wants to know, is radioactivity a problem with working with lanthanides and actinides or just specific isotopes of them?
Yeah, good question. So amongst the lanthanides, and for people who don't know, that's the row that's on top, at the bottom of the periodic table. Most of those are not radioactive. Most of those are really stable, although they do have some of them have isotopes that are radioactive. Yeah. The exception is what is it? Protactinium, right? That's the one that's between cerium and neodymium.
I do not know that portion of the table as well as I perhaps should.
That guy is not good, not well behaved. But the rest of them are pretty much, no big deal. We have lots of them in my lab and we handle them. In fact, they just look like little pieces of metal. Mm-hmm. And fun thing to know, gadolinium actually goes into a ferromagnetic state close to room temperature. So it's a nice thing where if you can get a piece of gadolinium, you can do an experiment where you can, heat it up a little bit. And, okay, here's a little bit of information about magnets. They can be paramagnetic, where they're not ordered, but the spins are just pointing wherever they want. But if you put on a magnetic field, they'll line up. Or when they enter the magnetically ordered state, they can spontaneously all line up. So gadolinium, close to room temperature, you heat it up enough, it's paramagnetic. It's not magnetic. You can put it on your refrigerator. It doesn't stick to it or anything. And you cool it down a little bit, it becomes a nice magnet.
You want to play again, or you want to try something
Let's
new?
try something else.
What do you want to try?
Let's see. How about it's not time for NARC yet. So.
What do you want to do?
Let's see. We had River City Ransom and
Battletoads.
Battletoads. Let's play Battletoads.
Battletoads.
Why
It is
not?
time to go back to Battletoads.
Yeah.
It's been a year since we played Battletoads on stream.
Well, it's a classic.
All right, let's get Battletoads
Okay,
up and
so
running.
where was I with this question? I don't even remember what the question was.
No worries. We'll get back to
actinides. Okay, so
32 Qubits has redeemed Take a Drink. Qubits, thank you for joining us. Pleasure having you. Cheers. Hopefully you have a drink at home, watching Ryan play Battletoads, talking about magnets and drinking alcohol. Sounds like an excellent Wednesday night to me.
oh yeah,
And we are to Battletoads. We are flashing back.
that's some good music.
Anyone wants to see the list of games for the night? There they are. Battletoads 1991. This was released.
I was just a kid.
I was 9 years old when this came out. And I remember playing this as a kid and just getting wrecked by it every time. Like you rent this from Blockbuster and you play it and you make it through 3 levels your entire gaming career.
Oh, take that, pig. All right, so actinides. Actinides are a whole other story. They are all radioactive. And, the reason for that is because they're much deeper in the periodic table. They have much bigger nuclei that are just unstable. Right? So
I'm going to turn up the game volume a little bit.
Got it.
You should press pause and have them jam to the...
Yeah, let's do it. Let's jam.
All right. How's that? Can you guys hear that? Perfect. All right, go ahead.
So, matters just get worse the deeper you go into the actinide series. Thorium is a little bit nasty, but it's really not that bad. We can handle in my lab. We have to be careful with it and monitor what we're doing, but it's not gonna hurt you that much. Well, you can't. I should be careful how I say that.
Yeah, don't eat it.
Don't eat it.
You're okay. Don't eat it. Don't get it in your eyeball.
If you have your gloves on and your lab coat, and it's okay.
Okay, enough.
Uranium, at least naturally occurring uranium, is also, more or less safe. Those are alpha particle emitters, and your skin protects you, more or less, from the radiation. They do have dangers associated with them that just have to do with being heavy elements. So if you got it inside of you, besides being damaged by the alpha particles, the heavy elements would probably poison you.
Like mercury.
Yep.
Yeah.
That wouldn't be good. But you know, Newton drank mercury, or so I've heard.
Newton did a lot of things.
Newton did a lot of crazy
poked
things.
his own eyeball.
I know. Can you believe that? Yeah.
I think he maintained his virginity because he thought it would mess up his thinking or something. Yeah, Newton was not a mentally healthy individual.
No, he wasn't. He was really into like the occult. And that sort of thing.
Yeah. No.
I'm not saying be like Newton. Oh,
Be a little bit like Newton.
be a little bit like Newton.
I mean, honestly, if you can change the way we think about physics and mathematics, be Newton, whatever. Just don't hurt other people. Only damage yourself.
I guess I probably have to pick up these rocks or something.
Yep, and then throw them at the thing.
You dang thing. Okay, but so things get much worse the deeper you go into the periodic or the lanthanide series. Oh yeah, there we go. Take that.
Nice.
And you know, as you make your way past uranium to neptunium, it gets pretty radioactive, but it's not that big of a deal. But if you get to plutonium or americium or and beyond, you know, that's pretty radioactive, pretty dangerous.
Yeah.
You can definitely get badly hurt.
There's different rules for handling those.
Yeah.
On the plus side, most of those elements are in very small quantities on the planet Earth, and you can't afford them. So
That's right.
like Einsteinium is something like 5 milligrams is $2 million or something.
Yeah.
So
Yeah.
and that's not even real money. It's priceless. It's absolutely priceless.
It's truly priceless. Yeah. Okay. You know, those sorts of elements too have incredible properties having to do with their magnetism, and the things that those electrons do that are in those electronic shells are really unusual and very different from what like a lithium electron would do, or you know, some of those are moving at relativistic speeds, so they have unusual properties having to do with that. But because they're so rare and hard to obtain, what we know about them is not very substantial. So pretty much anything that anyone can do in studying those is intrinsically valuable.
Yeah.
Like new knowledge.
It's new and publishable.
Yeah.
Fun factoid about this level, I learned this watching someone speedrunning this recently. If you kick those crows over and over again, you can actually get one-ups if you kick them enough times. If you bounce, you know how you can hit them over and over? I did not know that.
Wow.
Like 7 or 8 times and you get one-ups from it, apparently.
There is no way I would get through this level without infinite lives.
That is the curse of Battletoads. All right, USB Mark wants to know. Nope. Wow, I thought the vitamin D3 thing I used in my undergrad research was expensive at 25 milligrams for $500. No, the most expensive stuff on Earth it's like the radioactive elements, the late actinides, right?
Yeah. I think that's got to be true.
And the other ones are actually some of the biomedical stuff is really, really expensive. Like certain lines of cells and certain drugs, and yeah, some of the most expensive stuff is synthetic molecules.
Yeah, that makes sense.
500 for 25 milligrams is still pretty expensive.
Pretty steep.
That's a stressful 25 milligrams.
I like to think about like iridium. I think I understand that comes mainly from outside of the
Asteroids.
planet.
Yep, asteroids.
Yeah, that's amazing. Yeah, and then the other thing that I learned is that, okay, so you could take a canister made out of iridium, and you could drop it from orbit and have it do re-entry. And because iridium doesn't oxidize very much at high temperatures, it would more or less remain intact.
It's just be an iridium bullet flying at Earth.
Yeah.
Oh man.
And so
that's one of the most dense elements, isn't it?
Yeah. Well, yeah, it's a heavy transition metal,
Yeah.
and so apparently, you know, sometimes organizations like NASA need to put some plutonium into outer space on things. So there's things called thermoelectrics where you can use a temperature difference to generate electricity. And in deep space, you know, if you want to make a temperature gradient, you might use something that generates its own heat, like plutonium. And the way that you can get permission to do that, apparently, is to seal it in a canister of iridium.
Well, yeah, and the risk is you can't just send plutonium up in a
Right.
rocket, because if that rocket explodes,
You got a problem.
you got a cloud of plutonium floating in the atmosphere. So they send it in an iridium bullet, essentially.
Yeah. It's pretty amazing.
Yeah, that's the clearance it takes.
I think that the scientists who are on the teams that put those things together have a pretty interesting job.
Yeah, better get your math right on those.
Yeah.
That's like when you're a kid, you're like naively, why don't they just send all the radioactive waste to the sun?
Yeah,
you know?
why not?
Well, because you got to
Pretty
get it
risky.
there. You got to get it there with
Yeah.
zero risk, essentially. Otherwise, just keep it at home.
I think my daughter asked me that the other day, and it was exactly that. Well, it's not a bad idea,
No.
but you gotta get it there without, having it explode.
You get one try. You get one try to do the most dangerous experiment in human history. All right. USB Mark wants to know.
Okay.
Oh, qubits. Take a drink.
All right, here we
I don't know
go.
if we redeem this. We'll redeem it anyway. Cheers, USB, or
Cheers.
32 qubits. Thank you for joining us. Yeah, for anyone just joining us, Ask a Scientist Gaming, mediocre gameplay, expert level science. My guest today is Dr. Ryan Baumbach. He's an expert in exotic materials, magnetism, topological materials. He works at the National High Magnetic Field Laboratory and is happy to talk about anything materials, magnetism. If you have questions, throw them in chat. If not, we'll keep catching up on questions we have. I still have a few from a while back. We got
Okay.
detoured by...
And I should add that one of the things that I truly love in science is making materials, like growing the crystals, and there's a whole science that goes along with that.
Yeah.
Yeah.
Glorified cooking.
Glorified cooking, absolutely.
It's what we do too with
it's
molecules.
Really fun. Uh-oh, what are these guys?
All right, USB Mark wants to know, does MRI machines work with superconductors to create such strong magnetic fields?
Indeed they do. That's exactly right. So, if I understand correctly, I gotta think for a second. Okay, so when you think about what sort of superconductor would be good, for an MRI machine, you basically need something that you can wind a solenoid out of. That's one thing. So it needs to be a material that's malleable, that you can make wires out of. But it needs to satisfy a few other things. I mean, for one thing, it needs to be a superconductor that operates at a reasonable temperature. A lot of superconductors are at extremely low temperatures, so they're not very useful. So that's one thing. And then the other thing is, remember the Meissner Effect. It expels a magnetic field. But actually, for all superconductors, there is some field that's big enough to make it not superconducting anymore. And that's called the critical field. So any good material for oh god, I remember this.
You ready for this? It's back. Just memorize it. It'll be fine.
Any good material for a superconductor needs to sort of satisfy all of those things at once. And nature is a little bit cruel because it turns out, now we've had 100+ years to study superconductors and make.
Oh, first try. Look at
Wow, that's a
Cheers.
muscle memory from way back.
that. You get a GG on that one. Well done, sir.
Oh no. So
Doesn't matter. You peaked. It's all downhill from here.
it really is. I remember this is where I would always mess it up. But okay, so most materials are going to be, well, I should say most materials are not really going to be good at any of those. They're going to have low TCs, they're going to have low critical fields, they're not going to be very good for making wires. But then you do find ones that satisfy one or two of those, but maybe don't satisfy the third. And so I think that the name of the game these days, in terms of trying to make materials that are good for that sort of thing, is, it's not just a matter of making like a high superconducting transition temperature, it's a matter of satisfying all of those things all at once. And nature is really not into giving us all of that at the same time. So that's the challenge. Oh man, see now.
Well, and the other thing about MRIs, I mean, you also have the detector, like the microwave source, and like those are getting so much better. Like you can get away with relatively low strength magnets and still get an MRI.
I think they're like 1 or 2 Tesla, aren't they?
Yeah, I think the standard one is 2 Tesla. There's like a 9 Tesla MRI. I mean, if you want to image something really exotic, but yeah.
And isn't it the case that the higher the magnetic field, it's like the higher the frequency you can put on it, and that gives you more and more resolution on the objects that you can actually observe.
I don't know that relationship.
Yeah. I think that's... So at the Maglab, and I'm not part of this, there's a group that's called... Well, it's basically an MRI group, but they have really high field magnets for imaging, and they can image really small structures in rat brains and stuff like that. And it all has to do with having high frequencies in... wow!
Nice. Get it.
High frequency.
You're going to beat this level tonight.
That would be
we're
like
not
a
stopping
miracle.
until you do it.
It may take a few hours.
That's fine. We got another 2 hours left. Speaking of which, we should do another prediction. Which one do you want to do?
Let's see here. How about... Well, let's just do first observation of superconductivity.
All right.
Let's see how that goes.
First
It's an easy one for
observation.
me because I'm going to be sucking at this for a while.
Just memorize.
Come on.
Yes. All right, so we're putting the person's name in there.
These poor toads.
That's fine. You have infinite of them. Before I post this, Faithful Fairy, wait, magnetic materials are grown like we do with protein crystals. How much black magic is it then?
It's a lot of black magic.
Yeah, there's no...
It really is.
There's no mix A and B and you get C.
No.
You mix A and B, you get Q, X, and Z.
And if you want to discover new ones, you got to do a lot of messing around in the chemical phase space.
Yeah.
Yeah.
Even if you have the right atoms, they don't necessarily organize
They don't
correctly.
even want to go together.
Yeah.
Well, I always feel like nature doesn't want to give us the things that we want. And we're asking for some really special things. Oh, come on. You're kidding me.
No worries. Oh no, I'll let you focus here.
Oh, yeah. Ah!
Right in the middle.
Oh,
I knew that was coming,
that
and
was
I said
just bad
nothing. No, it's the same pattern. It's always in the middle there.
okay. If I can get back to that point, I will.
Yeah, just remember that. That was awesome. That deserves a rage.
So close. Oh, you dumb toad.
But yeah,
All right.
atoms don't always do what you want them to do. And that's the worst part, is there's like theoretical calculations that says if you make this, you solve every
Right,
problem,
right.
and you can't make it.
Yeah.
It can't be made.
Yeah. Have you heard about metallic hydrogen?
No, I have not.
Okay.
I know Eugene DePrince does calculations on theoretical things like that.
So metallic hydrogen is a thing that people have wanted for a long time because it ought to be a very high temperature superconductor.
Huh.
But hydrogen, of course, is a gas to start with. And, that's because it's a light element. It doesn't want to stick together. Hold on.
Yep.
I got to talk
Focus.
about metallic hydrogen. It's super important. No, you stupid thumb. Good God. It's like, no, you need to go into the middle of that. Okay, I'll try and talk about metallic hydrogen. So hydrogen doesn't want to stick together. But the idea is that if you could, that maybe what I need to tell you is that the way that Cooper pairs form has to do with an interaction with the crystalline lattice. Remember, there's an attractive potential that gets basically set up by the interaction of the electrons with the crystalline lattice. And it has to do with how those atoms are vibrating, because, atoms are always vibrating. If you could get hydrogen to stick together like that, that vibration frequency would be really high.
Oh, it's because
Really
the mass
high.
is so low.
Uh-huh.
Yeah.
And that is something that influences a superconducting transition temperature, at least for that type of superconductor.
I see. So it's really the mass. That's what drives that?
Yeah. Huh? And so people have been really obsessed with getting metallic hydrogen for a long time. And the way that you could imagine doing it is if you could pressurize it, like really pressurize it like crazy.
Oof.
Yay.
Nice.
Okay, so that's the idea, and there's people who have really, their entire research program is built around high pressure physics. How do you really hit these super high pressures? And the way that, oh boy, what's this? Okay, so the way that you can do that is using diamonds, right? Like, so diamond is incredibly hard, and you can make incredibly small faces on it, on the culettes. And then if you just put two culettes together and push them together, the pressure is the force per area. If the area is real small, you get real high pressure. Oh boy. Okay, I'm gonna have to figure this out.
No worries. It's the same every time.
So you can make, no. You can make real high pressures, but still not high enough to just metallize hydrogen. But you can put hydrogen together with other light elements, like sulfur, and I'm getting awfully close to the answer to one of the other questions, so I won't say it. But you can pressurize that stuff and actually get it to solidify, and when it does, sure enough, it becomes a superconductor. And I will say no more than that, because it's one of the questions, but...
Sounds good. Well, let's pop up our superconductivity prediction. Ladies and gentlemen, spend your standard internet units right now. We're going to put the prediction up. The question is, when was the first observation of superconductivity? And this is by Onis, the person that's credited with it. Was it pre-1900s or post-1900s? As in, was it within the last 120 years or before that we first observed superconductivity?
That's a good one.
Any additional details? No, you can't really. It'll give away too much.
Well, while they're looking at it, I want to say something about where Onis did this. This was actually, it was in the Netherlands, and it was one of the very first industrial scale research laboratories ever in the history of the world.
So that's a follow-up. I mean, when was the first industrial scale?
Yeah. Well, I think it...
Oh, sniped out of nowhere.
I think this one truly was the first, and what they were after there was how to liquefy gases. That's what their business was. They, it was when they were still learning about what's in the periodic table and isolating elements, and part of that business was, isolating gases and that was close. So they were not in the business of looking for new electronic states, but because they were trying to liquefy gases, they kept getting to lower and lower temperatures, and so they had this new capability, and they're like, well, what else can we do with this? And that was one thing they could do, and sure enough. Oh, yeah, you guys, you stay back there. No! Oh, no!
All right, you guys have about 30 seconds, 20 seconds. First observation of superconductivity, pre-1900s, post-1900s. Throw your guesses in there now. Spend your internet units because they're useless everywhere else, and they're just fun to guess. So make your predictions. 5, 4, 3, 2, 1.
Oh, cuts in there.
So we got 2 for pre, 1 for post. 97% of the funds bet are for pre-1900s. What's the answer? What's the year?
It is 1911.
Ooh, post-1900s.
Which, if you think about it, is incredibly recent.
Yeah, that's the last 110 years.
Yeah.
So, congratulations on your 32-to-1 payout. Faithful Fairy, congratulations, rolling in the standard internet units for guessing post-1900s.
Nicely done.
Yeah, I mean, that is a recent discovery.
Yeah.
Like, a lot of these questions we have on here are, like, usually pre-1900s, but superconductivity, fairly recent.
Yeah, and I think, that there's many ways to look at that, but I think that one thing that it emphasizes to me, that's recent history. And it's got to be that there are other, like we were saying earlier, other states of matter that we just haven't come across yet. And we just need more time. We need more special capabilities,
More money.
More money.
Personnel.
And we're going to find more stuff. There's got to be more stuff. Electrons are incredibly versatile. and we haven't explored that much of the phase space that's available. So
Faithful Fairy used their winnings from that to request take a drink.
Ah,
so, Ryan,
very important.
Cheers.
Cheers.
Thank you. Congratulations again, post 1900s. 1911. Superconductivity has only existed, as far as we know, for 110 years or so, which is pretty incredible.
Pretty incredible. And since its discovery, it has been the focus of so many theses, and research work, worldwide. It's driven the field of condensed matter physics in a big way, and it's a type of field that gains new life over and over again. So something that's important to know about the superconductivity that was discovered in 1911 is that it's a type that is phonon mediated, right? Like the reason the electrons pair is because of phonons, the lattice vibrations. Well, it turns out that that's not the only way to get electrons to pair up to form a superconducting phase. There's a whole other class of so-called unconventional superconductors where something else makes them pair up, and it may actually be spins, magnetic spins of other atoms that are present, in a material. And the energy scale of those spins can be completely different from the phonon energy scale, and that can let you get superconductivity at much, much higher temperatures. So that's a whole other thing that people are interested in, is like, how do you get electrons to pair using different mechanisms? So we're always trying to get materials into situations where other interactions might be possible to use to get electrons to pair up. So that's really where the field is at now. So those are called unconventional superconductors.
So Kite, I didn't see the notification, but thank you for the follow. Again, enjoy your standard internet units. Also, thank you for joining us. If you have a question, throw them in chat right now. We will get to them. It takes time because we wander throughout everything, including Battletoads, as well as a whole bunch of different science questions, but we will get back to them. So throw them in chat. I promise we will get to them. And if we don't, throw them in there again.
Absolutely.
Speaking of which, we have one from a while back. Scuzzbot Wotus wants to know, do you think a magnetic monopole will ever be observed or created?
Oh boy, the magnetic monopole.
The mythical, the legendary.
Well, I think that if you have a lone spin, that the answer is no. I think if you've got a lone spin, it's not going to happen. But I think that in the solid state where you have lots and lots of spins, that I got to figure out how to get off.
So the first ramp, I think you don't hit jump, and then the platforms you do hit jump. So if it's a ramp, don't hit. This is what we learned with David Collins, whose brother was actually in the chat and corrected his gameplay. George Jettison, where are you now?
So on these ones coming up, I should not hit jump.
If there's a ramp, don't hit jump.
Okay.
If there isn't, then hit the jump button.
All right.
If I'm remembering correctly. Jump.
Yeah. Okay. All right. So magnetic monopole. Okay. So the point is that you would like to have a object where the magnetic flux sort of just goes and diverges out from it, right? Like that's what we would be looking for. And a spin itself always has the magnetic field lines like looping back on the object. So a single spin's not going to do it. But if you get a
ooh, that was close. A little bit longer on the jump.
Okay, I gotta hold that jump down.
Yeah.
So in a collection of spins, maybe it's possible. Maybe you could get them set up in just the right way that those flux lines would add up to make something that looks like a magnetic monopole. I think I've heard that's possible. Yeah, it looks like.
Yeah.
I think
so. It's field shaping. It's not actually a true.
I think that's right.
Yeah.
I didn't know.
No worries. Let us know if you're gonna rage. I like it.
So
the answer is maybe.
Maybe. Yeah, I'm for sure people want it. Oh, you know what I think I'm doing? I think I'm too close to the bottom of the screen too.
may be the case. So 32 qubits followed up with people just simulated spin liquids at Harvard, another state for the state zoo.
Yes. Oh, the spin liquid is really cool. So the spin liquid is a thing that you can mathematically be certain exists in math land.
Reese's Pieces, you hear that? It's true.
It's a real thing. I mean, and people are spending huge amounts of effort to try and get a spin liquid.
Yeah. So what's a spin liquid for the naive?
Okay, so what's a spin liquid? It's a thing where you do have magnetic interactions. Okay, let me think about how to say this. So you do have magnetic. Let's jam out for a minute. Okay.
All right.
So in a regular group of spins, it's totally possible to have a group of spins where they just don't have any interaction between them, so they don't order. That's fine. That's just a paramagnet. And in some sort of sense, that's a spin liquid. It's a not ordered ensemble of spins, but we don't care about that. That's a trivial spin liquid. Imagine instead that you have a bunch of spins and they do have a spin interaction. And so it means that they would like to order magnetically. But for a spin liquid, there should be something that interferes with that, right? And so even though one-to-one they ought to order, then when you have the whole group of them, there might be something that is preventing that from happening. And we sort of generally refer to that as magnetic frustration. So it's frustrated. It can't do its ordering. So, okay, that's what a spin liquid would be. It's something that would like to order if you're just thinking about interactions between spins. But when you have the whole object, it can't quite get there. What's really challenging about this is that nature... Okay, yeah, let me put it this way. Okay, so you know about entropy, right? Like, entropy is the amount of disorder that's in a system, and nature does not like to have a whole lot of entropy at zero temperature. Right? Like, that's a big no-no. And a spin liquid is a thing that has basically all of the configurations that the spins could possibly take being pressed all the way to zero temperature. And that's an incredibly high entropy state. And nature really wants to get out of that. And so it looks for ways to get out of it. And so far, every real system that we know about that could be a spin liquid and seems to show some spin liquid-like properties, more or less is messed up in some way. And sometimes it's because of crystalline disorder or chemical disorder, or maybe the system eventually finds magnetic order somehow. Some people think that it might also be a good way to induce other states of matter, right? Like if nature wants to get out of the spin liquid, maybe it's just going to enter some new ordered state, like a crazy exotic superconductor, or, who knows what. So I don't know how to really answer that.
Yeah.
But
No, it's a hard question.
Spin liquids are super important, and experimentally they're extremely difficult to actually uncover because of this issue of having all this spin entropy at low temperatures, and nature hates that. Really hates that.
Oh, nature's making our life hard.
Making it hard. Making it real hard.
All right, we should throw another prediction up because we have a bunch.
Okay.
Through our brainstorming over the last week.
Yeah. All right. Oh, this is a good one. Kamerling Onez's thesis topic.
This is a fun one.
Yeah.
All right. So this is the first person. Let's not give away too much details.
This
All
is
right.
a good one.
Standard internet units. Spend them now. We're going to throw up another prediction, another science question. Ask a Scientist Gaming honor code. Don't look up the answer. Just do your best guess or know the answer. It's totally up to you. So how do you say the first name here?
I think it's Kamerling.
Kamerling Ona's PhD thesis topic. Is it the Earth's rotation or superconductivity? I don't know how much we can say to give this away. Most people probably don't know who this is, but we talked about them when we talked about the discovery of
Talked about it a
superconductors.
little bit. Yeah.
Go ahead and throw your guesses in there now.
Doesn't everyone know Camerling Ones?
No, you put that name in there without a
You're like,
qualifier.
who
I
is
was like, oh, this will go over well. You know, it's fine. We'll see how it goes.
This is definitely my condensed matter bias coming through. Like,
Yeah.
how can anyone not know who Camerling One is?
I mean, so
is
this
absurd.
This is the founding fathers of.
Yeah, probably one of the most important characters in condensed matter physics of the past 100 years. There's a good hint.
I mean, we have our previous answer.
Okay, I
Oh,
think
man.
what I'm doing wrong is I gotta hit jump off of. See, these ones you don't have to hit it, but this one,
I think you have to hit the forward arrow.
maybe it's the forward arrow.
Yeah, I
Okay.
think you have to do forward when you're in the air. All right, you have about 45 seconds. Only PhD thesis topic, Earth's rotation or superconductivity. Everyone is betting Earth's rotation.
Yeah, that's very smart.
Don't give it away. There's still 15
there's
seconds
still
left.
going, sorry.
Somebody go against it. Somebody bet against the odds. We'll see how it pays out. 10 standard internet units on superconductivity. I mean, so here's one of the problems with these questions is that there's meta information in asking the question. In
Yes.
that,
Yes.
why would he ask if the answer wasn't X?
Yes.
And so I fear that might have happened with this question because everyone guessed Earth's rotation. The answer is Earth's rotation.
Well done.
Everyone,
Well done.
congratulations.
Well done.
You win no internet points, but you can
I'm
feel
sorry,
good for
everyone.
getting this answer correctly. So Earth's rotation.
It's
That's-
pretty crazy, yeah.
So they eventually discovered superconductivity, but as a graduate student,
Yeah.
Earth's rotation.
Earth's
How does
rotation. I guess that was a
career
big.
trajectory unfold?
Who knows?
You
I mean,
have no idea.
I have no idea. I don't want to speculate on that. I mean, how does someone become the head of the first industrial
Yeah,
lab?
no, that's true.
Because, yeah, you're right. You got to press forward. That's the.
So were they actually doing the research, or they were a figurehead? Because it's
Oh,
like
I think he was actually doing the
he
research.
was actually involved.
Yeah.
Okay. Because like
Yeah.
Shockley, there's a lot of controversy on
Yeah.
how much he was actually involved in the transistor and so
Yes.
on.
I heard a crazy thing too about that with respect to purifying the germanium. Right? Have you heard this thing?
No.
So apparently they were having all sorts of trouble because what was it? Let me see if I can remember this. So they wanted to use silicon. Maybe I don't want to make stuff up, but in the end, they got it to work because one of the lab technicians made a decision that he thought the problem was that the germanium just wasn't clean enough. And no one ever, people were thinking, yeah, that's dumb. That's probably not what's going on. But he just went ahead and electro-refined it, which is where you pass a big electrical current through something and it drags out impurities. And sure enough, after they used that nice clean stuff, it worked.
That's awesome.
Yeah. So, a lot of times advisors may say to you like, that seems kind of like not the right approach. And you got to listen to your advisor, but they also might just be wrong.
Yeah, that's true. Don't always assume they're wrong, but sometimes.
They might be. Well,
Occam's razor, maybe they're wrong.
yeah. And I think
Oh, that was a good one.
that's a good one. I think that professors and PIs get sort of used to doing things the ways that they've had successes, and then maybe are going to be missing possible solutions. I don't know. Research is hard. I guess that's all I'm really saying.
No, it's true. Well, and people are hard, right? There are certain advisors that just want students that agree with everything they say.
That's right.
And like the yes men scenario, the
Yeah.
Donald Trumps of the world.
Yeah.
Not to
that's
get
true.
too political, but there are people that don't want students to argue with them.
Yep.
I'm the opposite. I'm really excited the first time my student argues with me and they're right.
I think it's too.
Like, no, it's
Yeah.
a rite of passage. It's when you transition from being a student to a colleague,
That's right.
right? Where you
Yeah.
can actually
I mean,
contribute productive intellectual things.
Yeah, what we really want are colleagues, new colleagues, right? I mean, I definitely don't want to just be in charge of someone forever.
Yeah.
That doesn't do much for me.
Twitcher follow-up, could you check the purity with spec readings? I mean, you could, but that was, when was that? That was 1950.
Yeah. They didn't have a lot of good technology at the time.
And even if you did, like, the accuracy of those, like, that's the problem with, like, semiconductors, is even a tiny impurity, like 1% changes everything.
These were incredibly small amounts of impurity.
Yeah, and that's all it takes to change, I mean, an insulator to a semiconductor, which is crazy, but that's what you do with silicon. So, yeah, you can do it. Now it's like, we reflect on it, it's easy to do, but they were jamming paper clips on germanium and getting it to be a transistor.
It's incredible that they even did
Yeah, that it worked at all. It's a miracle.
And isn't it true that for that they had the theory before they actually made the thing?
Yeah.
That's incredible.
I think that's most things, right? That's the laser. That's, you know, a lot of the optical phenomena. Like, yeah. Are you sick of this?
I think I'm done. I don't think I can get through this.
It's a pain in the ass.
It really is.
Do you want to go to River City?
Let's go to River City.
All right. We're taking a journey away from Battletoads.
Some I don't know.
No one is yet to beat Battletoads on our stream. Because it's a hard game, ladies and gentlemen.
It's really tough. All right, here we go.
The hardest part about research is that you're constantly failing. Yes, that is also the hardest part about Battletoads.
That's right.
Battletoads is a metaphor for research.
Yeah.
But no, it is. I tell students that, like, if you can fail 95% of the time and 4% have minor victories, 1% have a major victory, grad school's for you, because that's what you do.
I think that's right. And the other thing that I tell students is that, you know, you're going to fail a lot. And so what you need is a high burn rate. You know, you do need to try a lot of things because a lot of things simply are not going to work.
And thick skin and be okay with failure, and it's hard.
Yeah.
Oh, and Twitcher, first time chat. Thank you for the comment. Thank you for joining us. And failure is tough, whether it be Battletoads or in research. I mean, that's why, like, and we joke about this a lot, but like mental health in graduate school is no joke.
Oh, like, it's really important.
Really hard on grad students. I remember my grad experience. It was emotionally trying.
Yes.
There are years when, like, literally years where stuff does not work.
Yeah.
And like, you blame yourself, you question yourself. Like Ryan said, turns out your advisor was wrong. You know, like sometimes that's the way it goes.
Yeah.
And it's, so grad students in the chat, you're not alone. All of us went through it, and it's tough.
I remember being an undergraduate. Oh, I must be in town now, so I don't have to fight anyone. I remember being an undergraduate, and it wasn't so hard. Like, it was, and then getting to graduate school, it was really eye-opening, because the people who were in my classes were so smart and so talented. I just felt like they were on another level. And a lot of them were. And then, you know, a lot of departments, you have to take a qualifying exam. Oh my. I didn't pass my qualifying exam on the first try. And that was mentally difficult. So I was used to being able to do things without too much trouble. So yeah, grad school's hard.
And it's a very different skill set than everything you've had before. And then you walk into it, and it's not what you expect. It's not classes. There's no right answers for most of it.
Ooh, guys with chains.
So yeah. But shout out to all the grad students, because the dirty secret is most scientific progress over the last 70 years is built on the backs of graduate students working terrible hours for minimum wage. So
That's true.
shout out to you for fighting through that and making success, because as my postdoc advisor said, you're here to make me famous.
That's awesome.
Is it though?
No.
No, he's like 80 years old. He's old school. But he was right? Like, anything I discover while I'm a postdoc or grad student goes to the advisor.
Yeah. So I was actually wondering, in your field, do you have the impression that most progress is made, or I don't know about progress, but is the usual process that theorists will come up with something and then experimentalists come along and test it and verify, or does it work different than that?
That is interesting. I think the major transitions in chemistry, I mean, like, birth of quantum mechanics was theoretical before experimental, right? So there's like, it's hard to argue with those major iconic changes.
And topology is the same way. You know, I mean, that change came from theory first.
But there's a lot of like accidental science discoveries that change the theory. I don't know how to answer. I think it's much more cooperative now.
I think you're right.
Because I think we're so well understood on most. Like, there's only so many ways you can organize carbon, hydrogen, nitrogen, oxygen, right? And like, I mean, I think it's more cooperative than it's been any time in the past.
Yeah. And I think there are some things.
We should do another prediction.
All right, let's do it. Record high. Yeah, that's a good one.
All right, we're just going down the list in order. There's no rhyme or reason. This is just how I put them in the Word document. Ladies and gentlemen, time to spend more standard internet units. This one should not be as obvious. We got a 4 to 0.
I will make no comments.
Yeah. No. Isn't it weird though? Like just the nature of the question. This is why I hate writing test questions. It's a very frustrating process. All right, prediction is up. Throw your standard internet units now. If you're not following, click the follow button, get your 300 points, spend them on this question. The record high temperature superconductor, is it greater than 0 degrees C or less than 0 degrees C? So these are non-American units. This is in Celsius. This is the freezing point of water. Greater than the freezing point of water, higher than the freezing point of water, also known as 32 degrees Fahrenheit. Is it greater than that, or higher than that, or colder than that? What does high temperature mean in the world of superconductors? I will leave it at that unless you have anything to add.
I will say nothing. I think I need to eat any of this stuff.
Faithful Fairy. The Making Me Famous one reminds me of Reza Ghadari and his students exposing him. I don't know who that is, but I'm going to look it up right now.
I want to know.
That sounds like a fun... While I look it up,
Sounds like
the question is, record high temperature superconductor. What is the highest temperature we've seen superconductivity? Is it greater than 0 degrees C or less than 0 degrees C? What's fun is I can see someone clicking the 10-point button over and over again. You can click custom amount underneath that and type your numbers in rather than clicking it over and over again. But yeah, what is the record high temperature superconductor? Professor of chemistry... Which one is this?
Where is it? Oh, that's Scripps?
Yeah. Oh, it's a web page. Oh man, uBlock Origin is preventing me from going to that page, so I'm not going to dive down that rabbit hole. All right, 5 seconds left. Record high temperature superconductor, greater than 0 degrees C, less than 0 degrees C, warmer than ice, colder than ice. Which one is it? Ryan, what is the answer?
So nowadays, it's pretty high. It's almost at room temperature. What was the actual number?
Greater than 0 degrees C.
Yeah.
So 15 is the number you sent me.
All right, then that's the number. The number is actually going up rapidly these days.
Qualifier.
Yes, there is a qualifier. So remember we were talking about metallic hydrogen earlier, and the idea that could be a very high temperature superconductor. Well, it turns out that now people have figured out that you can take some mixtures of hydrogen and other elements like sulfur, or throw some carbon in there, or other elements too, and pressurize them to extremely high temperatures, something like, what did I say, 200 GPa, gigapascals?
Like 267 gigapascals.
This is something like 3/4 of the pressure at the center of the Earth. Which is an incredibly high pressure. And sure enough, these things turn out to be very high temperature superconductors. And so now people are working on these different cocktails, different mixtures of elements, tuning them up, trying to see who can get the highest temperature superconductor. And that number just keeps going up. Now, you might say to me, oh, this is okay, fine. This is just sort of a party trick. And in some sense, you're right. We're not going to make useful tools out of things at such high pressures. But there is such a thing as metastability. So there's some materials that once they wouldn't just form under regular conditions, but once you get them to form, they may stay put together, right? And, there's a variety of materials that are like that. And the hope is that one of these things will actually turn out to have a metastable crystal structure where once you pressurize it and make it, it'll stay. And then you'll have your nice high temperature superconductor. The other hope is that maybe by studying these things, you can learn enough about the basic science behind them, that maybe you could make this behavior in other materials.
A dude just sprinted at you and threw a chain.
No.
That was amazing.
You see why this game is so great?
DJ Terraform, this is a Poe's Law. I can't tell if this is a troll or not. Listen to this. Hi, Professor. I have a product prototype and I want to present a great business opportunity to you. I've developed a free energy machine based on Brazilian cashew nuts, and I'd like you to be my first investor. Would you like to join my startup and help revolutionize the world's energy mix? One, if you're looking for investors, do not go to professors, because we do not make that much money. Go to someone that makes bank and go after them. Faithful Fairies reply, will Georgian pecans work with this wonderful machine? If so, I'm in. I just, DJ, I'm breathless that you took the time to chat that. I can't believe it's real, but maybe it is. Who knows?
Well, I got no money.
Exactly. Sounds amazing. Make it work. Solve our energy problems.
You never know.
Yeah. Quick question from Twitcher. Do undergrads generally take PChem? Depends what major they are. If they're chemistry majors, absolutely, it's part of the degree. Chemical engineering, they have to take the first PChem. I think they have to take quantum.
Okay.
Biochemistry, I think you have to take one of them. It might be thermodynamics, but not mandatory. Again, it depends what kind of degree you want to go after. So,
Yeah.
maybe.
I think it'd be super uncommon for a physics person to do that, but not impossible.
Yeah. I mean, physics, if you take modern physics, it is equivalent to quantum
it?
mechanics.
Oh,
mean,
sure,
it's
sure.
slightly
Yeah.
different language, but for the most part, it's the same thing.
Yeah. Absolutely.
Perhaps I can instead invest my points from Stack Exchange. Dude, you take standard internet units, because I have infinite of those as host of this channel. I will invest that in your nut machine. Oh man, that's a Sagan, deity Sagan right there. Oh man.
I frequently get emails from people in the public about machines of various sorts.
Oh really?
Yeah.
Just,
Yeah, Maglab employees get contacted by a lot of people.
Holy shit. It was like my second year as a professor. I got a letter, a handwritten letter from someone.
Wow.
But it was intense. It was like, it was nonsensical gibberish, but it was talking about, and I don't know how they found me, but they're like talking about wavelengths of light and how those wavelengths interact with organs, and you can treat organs with that. And like they were alluding to photodynamic therapy, but in a really crazy way. Like liver cancer has a certain frequency, and if you tune to it, and it was...
Yeah.
And it was like, I showed it to Debbie and she was like, Ken, don't get murdered by a lunatic. And I'm like, that's fair. Like, I'm not going to give him my home address to have a conversation or anything. But it was like a year later when I got another letter. And so this happened annually for about 3 years.
Wow.
And I have these in my office, but I haven't gotten another one since.
Wow.
And so I don't know who they are or where they're, I mean, I can look up the return address, but they found me online talking about wavelengths or light matter interactions or something. I don't know.
Yeah.
So
Yeah. Well,
it's not a cashew machine or whatever we have going on here, but nonetheless, let's solve problems.
Yeah.
All right. Faithful Fairy wants to go back to, I feel like this question is too late, but what is condensed matter physics really? So we've had on this channel, we've had an astrophysicist, we've had a particle physicist, we've had Hanwei's condensed matter physicist.
Yep.
You're the second condensed matter physicist, and we probably haven't really answered this question yet. So what is a condensed matter physicist?
I think... I don't know if I can answer that with a complete answer, but to me, what a condensed matter physicist is interested in is more or less the behavior of electrons in solids and the behavior of nuclei in solids. I think that's fundamentally what we're talking about.
Yeah.
And then I think those are our building blocks, and so what we're really interested in then is what sort of collective states can be formed out of them. Right? So you could have, if it's just nuclei, you could have structural phase transitions. I mean, even the question of why does something form a crystal structure is a pretty fundamental question. It's not totally clear to me, at least, why I mean, I know it's the lowest energy state, but why is it the lowest energy state rather than just a random mixture of a bunch of, stuff? Mm-hmm. I don't.
Yeah.
I'm not sure
Why
that's
is it
actually
crystalline at all? Why isn't it amorphous? Yeah.
So, okay, we care about that sort of thing. And then once you get electrons in the mix, then you have all sorts of new collective modes that can emerge, and we just care about which ones can there be and how can we use them, and I think that's the name of the game. That's what condensed matter physics is.
I think 32 qubits has an important follow-up. On top of that question, is ice cream condensed matter physics? If yes, I think funding is advisable.
I think it is condensed matter physics, for sure. It might be like soft matter, but...
Soft matter.
But, yeah.
Soft condensed matter physics. We'll count it.
I'll take it.
CXE has a comment in-game. You got to spend some of that money you earned at the Sushi Bar in town.
Okay, where's the town? Let's see. Is it this way? Maybe it's this way.
CXE, if you know the answer, I've not played this game at all.
I'm kind of just wandering around.
I own this game and I have not played it. Can you make topological ice cream? Sure. It depends what your definition of, or your specs for topology are.
You can just put a hole in it.
Oh, there you go. Sushi Bar.
There's the Sushi Bar. All right, let's get some sushi. See this? This is the game from, is it the 80s or the 90s? And they got the guy eating sushi and stuff?
Let's see.
I don't think I should buy cheaper sushi.
So this one was 1989.
89. This game was ahead of its time.
I mean, how much is the expensive sushi?
So you got the mixed roll for $10.50.
What does this do? Is this health? Is that what we're doing right now?
Sea urchin. Whoa, swordfish.
You don't have enough money.
I cannot buy swordfish. I don't know if I have $9.80 or $20. Let's try and buy some halibut.
Yeah.
It is what I would like.
We're learning things tonight, lady. No, you're broken. No, you can buy some salmon.
Oh, he kicked me out too.
Well, I mean, rightfully so. Don't waste their time. Be able to count your money before
I must have $9.80. Maybe my wallet can only hold 20. Let's see.
All right, Reese's Pieces. I've heard a few crazy stories from cranks, people who aren't academically trained who are convinced they solved one of the foremost problems in an area that no subject expert knows how to solve. I mean, that's the quintessential pain in the ass of being an expert and listening to non-experts.
Yeah, huh?
Like,
that's pretty routine.
Like, I saw the thing that no one that has studied this for a lifetime has managed to see. Mm-hmm. Man, my favorite one, so we used to do the in-person Ask a Scientist, and it was like Railroad Square Park, and people would show up and they'd talk to us. Yeah. There was one kid that showed up, and it was me, David Meckes, and somebody else. David Meckes is a virologist in the biomedical program. And this person was going to convince us that fruits were the cure to every disease. And like, he was on a fruit-only diet, and of all the things that cancer researchers have studied, they missed that fruit was the answer. Somehow that was the variable that we hadn't caught before.
Wow. Yeah.
Anyway, sorry the detour on the rant.
Yeah. Yeah.
It's just so frustrating. Like, people study this for a living, and somehow just anecdotally, I mean, even like economics and trying to describe the entire economy, or cancer research, or most recently COVID. Mm-hmm. Like, your Facebook posts somehow have more information than our journals.
I know, it's painful. It's so painful.
I'll stop ranting. It's not about me. My guest today, Dr. Ryan Baumbach.
I feel the same way.
It's infuriating. What do you do about those?
I have no idea. Actually, one thing that people in science are not especially good at is communications and figuring out how to manage those sorts of things.
Yeah.
I mean, we have practically zero training.
Well, the other thing is, I mean, beyond that is we're not good at propaganda.
No.
Like, we're not good at concerted branding and selling it together. We can't even agree on where an electron's going when you hit something with light, let alone like how to solve a big problem.
Yeah.
And so like our own critical lens is our worst enemy in terms of propaganda, at least.
Absolutely.
Carl Sagan said the same thing.
Yeah. Oh.
Yeah, I don't remember which thing in particular, but it's probably the same idea, right? You're herding cats to get them to do something, whereas herding sheep is a lot easier. So Facebook, kudos to you for solving that problem for being stupid
Thanks,
people.
Facebook.
Exactly. We just need a Facebook of only scientists, and then no one will agree on anything. It'll be constant fighting.
I was in college when Facebook first got started.
Oh, with the EDU address you signed
and
up.
it was really fun.
Yeah.
I mean, it was really fun. And it was when only college students were on there.
Yeah.
And just my friends were on there. You know, it seemed really special and fun. That was it's different.
Cuddle puppy. Okay, it's kind of horrifying to hear the guys you beat up crying for their mama.
Yeah, it puts the text at the bottom of it.
Yeah, no. This is more horrifying than Castlevania.
This is the generic dude's turf. Barf. Can you believe it? You just pick this guy up and throw him. Pretty crazy.
Yeah, Carl Sagan often stressed the importance of scientific communication to the general public and felt most scientists were very poor at it. Yeah, it's a unique skill set.
Yeah.
I mean, we have to drink alcohol and play video games to even attempt it. So
Right. Still we're not.
but kudos to D.D. Carl Sagan, who actually did it and did it really, really well on the national scale. And there are people working at it, but it's hard.
Yep. I mean, for example, at the Maglab, we've got Kristen Roberts and her team.
Yeah.
So we're very grateful to people who can do that.
Yeah. Shout out to Kristen if she's in the chat.
Yeah.
Because we have to do it.
Yep.
All right. Barf. We should probably do another prediction. We're at 9:40 and we have a bunch of these.
All right.
We did that one
one up.
already.
Oh boy, now we're getting into the ones that I don't know off the top of my head. Stronger magnet. I'll say nothing.
Do it?
Do
All
it.
right. All right, another prediction. We have a whole bunch of these. We spent the week brainstorming, and I think we came up with some fun ones. I like the coin toss nature of some of these questions. All right, we got another prediction up there right now. Ladies and gentlemen, if you're not following, click follow, get your standard internet units, and bet them on which has a stronger magnetic field, the Earth or your fridge magnets. And so this could be anywhere on Earth. This could be the core of the Earth. This could be on flux lines. Fridge magnets, this is your standard fridge magnet, not an MRI-based fridge magnet. This is just what you literally have on your fridge from the auto shop or whatever
No
company's
neodymium iron fluoride magnets.
Exactly. So which one's stronger, a fridge magnet or earth magnet? Earth magnet at any location. So we're going to give it a range of potential values. Where is the Earth the strongest? That's what we're using as our metric here. So throw your predictions in there right now. Which is stronger, fridge magnets or Earth magnets, or the Earth? Is this a trick question? I
don't think so.
No, I think it's pretty straightforward. If you think it's trick, I'm curious how. Trick question. Neither have magnet fields. No, this one, it's both have a magnetic field. The question is, which one is stronger? Of our questions, this might be the most straightforward tonight.
Yeah.
Yeah, I think so.
Yeah, it could be.
So yeah, don't overthink it. Don't try to go meta. Just answer the question as you feel right. Is it fridge magnets or Earth? Throw your prediction in right there. My fridge is part of the Earth, though. Oh, fuck! I would give that student credit.
Yeah.
So, Cuddle Puppy, if I could give you free internet points right now, I would. So we're gonna say the magnetic field induced by the core of the Earth. So that's what we'll say when we're saying Earth.
Okay, fair enough.
What an amazing loophole. Kudos to you. I really love when people find holes in our
It's good.
questions.
Yeah.
That's clever.
You're
as
clearly
fuck.
a lot smarter than me.
Exactly. So last minute guesses, 5 seconds left. Fridge magnets or the Earth, which one is stronger? All right, and our answer is
Fridge. Oh, is it my turn?
Yep.
So we'll say fridge magnets.
fridge magnet.
Incredibly.
So we looked up the numbers here.
Yeah.
So fridge magnet is about 0.01 Tesla,
Or 100 Orsted.
and the Earth is 0.000065 Tesla. So
Which is
fridge
very
magnet
small.
is a lot stronger, like 100 times stronger. And that's even the highest Earth field you could possibly have. The fridge magnet is much higher.
And I think that I think that intuitively makes sense.
Yeah.
I think because your fridge magnet, you take it up to your fridge and it actually sticks to it. Mm-hmm. if the Earth's magnetic field was that strong, I think if you laid your fridge down on the ground,
You can never pick it up.
a lot harder to get back up.
Yeah. Well, also, if you guys have ever played with a compass, like not your iPhone compass, but like a true compass that has a metal pointer on a wobbly mount, like the Earth is not very strong in directing that field. But if you take it next to any magnet at all, like even a cell phone, like it'll turn that, it'll screw up that field. So
yeah,
it's a lot faster. But it was crazy, the numbers. I'm gonna throw them up there for you guys right now in chat if you guys want to see. This is at least according to Wikipedia. Fridge magnet 0.01 Tesla, the Earth magnet 0.00000065 Tesla. And to give context to that, what did we say? The magnet that picks up a car is like 2 Tesla, right?
Yeah, I think that. Yeah, that makes sense. It might not even be 2 Tesla. It might be more like 1 or less. But
yeah, like an MRI is like 1.5 or something like that.
And the one picking up the car is an electromagnet. So if you, at least ones that I know of in the lab that are electromagnets, 1 Tesla has got to be like water cooled. Otherwise, that sucker's heating up pretty fast.
So if you buy like a 1 centimeter neodymium magnet, that's like, how much is that? That's like 0.5 Tesla or something, half a.
Yeah, that could be.
Or up to 1 Tesla.
Yeah. They're pretty strong. You know, you can buy permanent magnets that are actually dangerous to you.
Yeah. There's a bunch of YouTube videos. You guys should look them up where they take permanent magnets and just smash them into each other, accelerated solely by the magnetic field.
It's scary.
It shatters them.
Yeah.
No, you can break fingers with those bad boys.
There's ones where if you carry it through a doorway that has metal framing, that it'll like, pull you towards the door. And, you gotta be careful with that stuff.
Yeah, we've used some of those for static magnetic field measurements. And they're scary.
They are scary.
I don't want to play with them.
No, I do not want to. I do not either. No, thank you.
Reese's Pieces has redeemed. Take a drink. Reese's Pieces. Cheers. It's a pleasure to have you joining us. You're on another one.
I'll dig into the bag.
Sounds good. Fridge magnets. What I love about fridge magnets is they were clever and they made U magnets, so it's unidirectional, right? And so this is such a minor development, but important if you want to advertise shit, right? So most bar magnets, you have a straight line and you have a north pole and a south pole, which means that either side could stick to metal. So what they did is they made really small U magnets, which directs the north and south that direction, and it can stick to the fridge unidirectional.
Oh, that's really smart.
And so they have the other side is exposed. And so if you take 2 fridge magnets and you actually put them face to face and pull them apart, you'll hear them actually vibrate. It'll be like ta-ta-ta-ta-ta-ta, and it's because you're rubbing north and south over north and south. And so it opposes and pulls, and you're actually jumping over opposition. Yeah. So,
that's awesome.
Fun experiment. It's at home sciencing.
Guy. Oh, he just hit me in the face with a pole. Did you see that?
Cuddle puppy. When you disrespect a guy so much that you throw a knuckle duster at him instead of punching him with them. You're not wrong. This game is amazing.
Yeah.
Disrespect. Oh, River City Ransom. This is one of the classics.
It really
is. One of those. It's like Double Dragon, but with storytelling and like character development
and text. You really know how they feel.
Yep.
Yeah.
All right, going back a ways, a big spooky skeleton. We've had this one on a back burner for a while, but I keep seeing headlines about time crystals. What is a time crystal?
Yeah.
I don't know what that is.
I am not super familiar with that either. So I'm gonna make a guess, and I'm not totally sure that I'm right about this, but I don't think that a time crystal is something that's made out of atoms. I think it's something that's made out of light, perhaps, and it's something that just has a repeating pattern in time, right? It's something that's periodic in time. And
I see.
You know what I mean?
Yeah. So it's a metaphorical.
Yeah, and I think that it's more complicated than just like it's not just a electromagnetic radiation, because that's periodic, also in time, but it's something that they've made. Maybe it's with the lasers interfering with each other. Or, I don't quite know, but something along those lines. At least I can't imagine, and I could just not be creative enough, how Oh, wow, I found a new part of the world. Look at
Nice. Congratulations.
I can't imagine how you would take atoms and have them be periodic in a special way in time in a solid. And I don't know how that would work, but yeah. So sorry for the unsatisfying answer to the question. Sounds cool. Learn more about it for next time.
A big Spooky's reply: if you don't know what the time crystal is, then I don't really know either. I mean, yeah.
Sounds like something from Doctor Who.
And this is a huge problem in science, is that nomenclature is a big thing, right? Like a definition of crystal, according to a casual observer, is something that looks shiny and reflective and has faces, right? But a crystal in chemistry and physics has a very specific definition. It's atoms ordered in a very specific way. And then you take something like a time crystal and you further bend what that definition is.
It gets confusing. You know, speaking of people that want to talk to me about things that aren't scientific exactly.
Yeah.
Crystals are a favorite topic.
Oh my God.
Yeah.
Like I remember distinctly one of Debbie's friends. I'm not gonna get into details, but it was like on Silly Putty. If you let it sit long enough, it'll grow like salt crystals on the top. And they were super fascinated. I'm like, it's not healing shit. It's not doing anything to affect your body.
I have high school friends who really are into the whole crystal healing thing.
Yeah.
Actually, my wife, when we lived in San Diego, she worked for a very successful life coach who was sort of a crank, and she believed in all this stuff, and she had a whole thing about how tapping people could heal them too.
Yeah.
So there's a whole tapping thing that went along with it.
It's another one of those, we missed it. Science has been trying this shit for centuries, and we just missed that. That was the answer. Just tapping.
Tap people the right way.
Tapping was the answer.
Yeah.
Cuddle Puppy. A time crystal is a plot element for sci-fi films written by screenwriters who don't understand science. Correct.
I'm fine with that.
Yeah, no, that deserves a sag, and well done.
Now we'll probably get some emails from some scientists tomorrow, like, come on, guys.
Have you tried homeopathic crystal therapy? It just really adjusts your chakras. Nope, we're not going down this rabbit hole. Time crystals will be a major plot twist in the next Marvel movie, probably. They had quantum tunneling last time, or what was it?
Wait, which movie?
The last Marvel movie.
The Ant-Man when he gets real small.
Yeah, the quantum something.
Quantum realm. Quantum, wasn't it?
But it was like a quantum tunnel to the quantum realm. Anyway, we're at 9:51. It's time to do another prediction because we're burning all these down. Should we do the next one?
Let's do it.
We're going to do another magnetic field measurement.
This one, there is no way to have an intuitive idea of what the answer is, at least as far as I can tell.
Well,
we'll see. We'll see. Maybe you'll all get it, and then
you are better than us. And this one isn't even easily searchable, but don't search, you're cheating. All right, start prediction right now. We got 2 minutes. We're going to ask which one has a stronger magnetic field, the toaster or the human brain. We're saying the average human brain, not special whatever human brain. We're saying an average toaster as well, just so no one tries to make a superconducting toaster for some reason. We're just doing which has a stronger magnetic field, the human brain or a toaster. Throw your guess in there right now. Not a Trump brain. Agreed. Well, there's the people that were claiming after the vaccine they started to become magnetic, and we're going to assume those are false. We haven't tested it, but we're fairly certain.
It all adds up.
So the question is, which one creates a stronger magnetic field? Is the toaster on? Yes, we'll say it's a fully functional operational toaster.
In fact, it's key that the toaster is on. Right?
I don't know. I don't actually know if that's true or not.
I guess that the toaster elements could be made out of something.
My brain is very electric, the best neuron, believe me. People keep saying my brain is the best brain and it's very electric. Nailed it, Reese's Pieces, thank you. Cashew magnets equal 100 kilograms of tapping time crystals. I see you're using American units here.
What's going to happen now is people are going to start looking up tapping and get inspired.
Oh, man.
Boy.
Hopefully to debunk it. Well, it's not even, that's the hard part, is it takes so much time and effort to debunk this shit.
And the other thing is how incredible the human brain is at believing that things are working, right?
Yeah.
So if some patient is believing that tapping is curing something, well, actually they might be getting a little better.
Yeah. Well, and that's the hard part, is like you don't want to if it's working, even if it's just placebo, you don't want to.
You don't want to mess with that.
Yeah, but if it's affecting other people, like your kids, or then it starts to become a problem, or it's debilitating, where you don't want cancer treatment because a magnetic bracelet's going to work.
Right.
So,
that's not great.
All right, stronger magnetic field. Is it the human brain or a toaster? This one's pretty closely tied up. This is 3-2, 1,000 versus 560, and the answer is...
It is the toaster.
The toaster has
at 700 nanotesla.
So I'll copy and paste these numbers in chat.
The brain has a measly 0.1 millinanotesla.
There's your numbers right there, ladies and gentlemen. Yeah. So very small, weaker than the field of Earth by, what, 4 orders of magnitude, weaker than a fridge by 7 orders of magnitude.
Yes.
So brain does have a magnetic field, but it is much weaker than your toaster.
Yeah. Maybe we could have guessed that because, I mean, how much electricity is really running around in your brain? I mean, it's not like you've got a voltage on your head that you can, put your head down and, well, I guess you can with the what do you call it?
Yeah.
Brain scan,
the ECG.
EKG? Is it
no,
ECG?
That's the heart. ECG is the brain, the encephalogram. I mean, they can measure that. I mean, it's enough. You can actually, it's nanotesla is measurable. That's
true.
So, speak for yourself. My brain is 92,000 Tesla. Wow. Cuddle puppy, you are smashing into like satellites with that type of field. Like it'll just lift you off the ground and you'll follow it around.
That's going to bring us to one of our later questions in a nice way, right? Or maybe not.
There we go. Next one. We'll
good.
hold off on that one for a little bit. First elite cyclists can beat toasters. Now brains can beat toaster. Can't beat toasters either. The Matrix was not that realistic at all. Not yet. Give it time. New states of matter. We'll see what happens.
I'm really hoping that the new Matrix movie is good.
I do too. I loved the first one.
Me too.
And then the second and third.
They were disappointing.
Yeah, they got too existential.
Yeah.
The fights were amazing, but so it goes.
That's how it goes.
Yeah. All right, ladies and gentlemen, it's almost 10 o'clock. If you're just joining us, my guest today is Dr. Ryan Baumbach, who's an expert at magnetic, exotic quantum materials, really making those materials and studying their properties, particularly magnetic fields. He works at the National High Magnetic Field Laboratory in Tallahassee. He's a research professor there, and he is happy to discuss anything, exotic materials, topological materials, magnetic materials, anything you want to discuss. Even we went down the rabbit hole to homeopathy and tapping as cures for things. So we're happy to discuss anything you want to throw in chat. Throw your questions in there now. My list is officially out of questions, so we have caught up with everything as far as I can see. If I missed your question and you want it answered, please throw that in chat now, and we'll get back into it.
Or just prepare to be horrified by River City Ransom.
I don't know. You're making progress, right?
I'm making progress. I mean, I made it to the part where the guys throw tires at you. That's pretty good.
Has this inspired you to pick up download an emulator and start playing again?
You know, I once tried to get an emulator together,
and
I don't remember what happened with that, but I must not have gotten very far.
I mean, if you get a USB controller, I can send you a link. And you will be up and playing River City Ransom. The thing is, you have to teach your kids old school gaming that are unforgiving.
That's right.
And there's no difficulty setting.
Absolutely.
It just abuses you like life.
Zelda is just so relaxing. It gives you the wrong perspective on life.
Yeah. Well, no, the modern Zeldas.
The modern Zeldas. The old Zeldas are pretty hard. I think the hardest Zelda was the second one.
Yeah.
Did you play that?
That was the one I played more, actually. That was my go-to.
Wow.
Link. Yep.
That was a hard game.
I don't know. I thought giant insect-like robots feeding on humanity was within the realm of possibility. Humans as an energy source is kind of dumb, though. Let's be honest. There's more energy burning us than trying to tap into our electrical potential. For real. If you can use a really efficient Carnot engine, I think it's more valuable to burn us. But anyway, don't quote me on that. Would you say Zelda is good practice for grad school? Oh, no, let's reframe that. What video game do you think most closely represents the graduate school experience?
Ooh. I mean, wow. I mean, you don't want to say like Battletoads because it's just too hard. there are good things about graduate school.
I have an answer if you want time to think.
Go for it.
I'm going to go with Tetris.
Okay.
Because, like, you battle to keep your shit organized and just stay on top of your tasks.
Yeah.
And if you screw up one thing, the pile goes completely wrong and you pray that you can recover from it. And you get that 4-line Tetris and you get all those points. Those are the minor victories under a pile of shit that you have to climb out of.
I like that.
So I'm going to use Tetris as my metaphor for grad school.
That's very good.
Battletoads.
I mean, Battletoads if you have a bad advisor.
That's true.
Yeah.
Yeah, we got to take that into account. Is there a boss? Is there an antagonist in your graduate school experience?
You know, I think it's really important. Like, if you're in the process of thinking about graduate school, you really want to think about the culture of the place that you're going to, because some of them really are very unpleasant. Yeah. When I was looking at graduate schools, thankfully I did go to a place that turned out to be nice, but I was not smart enough to think about that sort of thing.
Yeah.
But I think you really ought to.
Yeah. I mean, it depends what you want to do, what time commitment, what kind of people you want to work around. Do you want to compete with your colleagues or do you want to work with your colleagues?
Yep.
And it's very different depending where you go.
Yeah.
Halo reached the final mission, survive. Oh, speaking of which, I'm thinking about picking up Halo Infinite. That's the new one, yeah.
Oh, boy.
That's what I played in undergrad. Halo is my go-to game.
Oh, boy.
I've played every one since. That might be my Christmas present to myself.
Cool.
But
I was really thinking about getting the Metroid game.
yeah,
The new one.
it's beautiful.
Yeah. But I told my daughter that, you know, we would play Zelda until we're done with it, so I'll probably hold off until
That's good.
that could take a little while.
Setting goals.
Yeah. If I get a new game, then I'll get distracted with it, and right now we're just enjoying Zelda, so.
No, I mean,
that
that's
could go on
awesome.
for a
You
long
can
time.
Play it with your kids. And
Yeah.
Spend time and discuss.
Quality time.
I mean, any time counts
It is
as
good.
quality time.
Yeah,
right?
no, I actually really enjoy it.
Yeah. Anything cooperative, engaging.
Yeah.
Yeah.
The only time it's not fun is, so all three of my girls will play it, but sometimes they also like to fight with each other. That can get a little vicious.
That's fair. All right, we're 10:01 and we have 3 predictions left.
All right.
We should probably do one now.
Sure.
Let's do one every 20 minutes and we'll call it.
Sounds
All
good.
right, which one do you want?
Let's just go down the list.
All right.
Record high DC current magnetic field.
All right, ladies and gentlemen, another standard internet units question.
In other
What's
words,
the-
if you put current into a solenoid, what's the biggest field?
Yep, so this is a continuous, this is not a pulsed magnet, this is a continuous magnet, a continuous electromagnet.
Yeah.
To give context, if you are going to pick up a car and in a waste management plant, it's going to be about 2 Tesla. The question is, how strong can we get our magnets? Is the answer greater than 30 Tesla or less than 30 Tesla? It's kind of a fun global competition. How high can you get your magnetic numbers?
It is. And it really is a global competition. Absolutely. I wonder how you get up these boxes. Seems
jump?
like you must have to get up the boxes somehow. Maybe you have to buy an item to be able to jump.
No idea how this
Maybe.
works. Can you get in the door? I don't.
Uh,
I got my PhD at Trump University. I learned how to bully undergrads. I mean, certain universities bullying undergrads is a rite of passage. I don't feel that way. I hate when people treat them that way.
yeah, I don't
but
like it either.
like that's a joke, but also that's a reality in certain research groups.
What university did you go to?
Did I go to? I went to St. Cloud State University, which
okay.
unless you play hockey or care about hockey, you've never heard of.
Is it in Canada?
It's in Minnesota.
Minnesota,
Close.
okay.
Close enough.
Cool.
So yeah, central Minnesota.
What was your mascot?
It was a husky.
I like it.
Yeah, makes
I like
sense.
it.
Cold weather.
I like it.
Where'd you go?
I went to UC Santa Cruz.
Santa Cruz. Okay, so
We
people
had
have heard of
banana
it.
slugs.
People have heard of
Love
banana
it.
slugs.
And when I was at UC Santa Cruz, when I was an undergraduate, we did not have grades to begin with. It was pass fail.
Wow.
And you got written evaluations, and it was all about community and
Wait, so applying for grad school, they didn't have a GPA.
So what happened about halfway through when I was there, they were in the process of transitioning over to grade.
I see.
And so not in the humanities, they really didn't transition. They may not have yet. I mean, they may have just refused to. But in the sciences, they knew that, you kind of had to do that. So I did have a GPA, but it wasn't for all of my courses. So my perspective on university was, I think, different than a lot of people.
Yeah.
I really liked UC Santa Cruz. It was so great. And it's such a beautiful campus. Like, that was one of the big draws for me.
Yeah.
There's redwoods and these canyons. And
That's fun.
So cool. Yeah. So then when I got to UC San Diego for graduate school, which is a more traditional type of university, it was kind of a shock. It's like, uh-oh.
Yeah.
This is something different.
Real.
This just got real. Yeah.
That's awesome.
Yeah.
I like it.
Let's see here. There was a store that was selling stuff. Where was that? I have absolutely no idea.
You have $13.
I think I've been losing money. I think someone stole some of my money.
I mean, you
I
bought
don't need this
sushi.
stuff.
No, you didn't.
I
So
did.
this presumably gets you health back. Is that
Gotta
what
be
this
for
is?
health. Recharge. Let's recharge. Let's see what happens. It is what I would like. Nothing happens.
Oh,
No.
death takes half your money. CXZ is our expert in this game. Death takes half your money. So you are
They have been stealing from me.
yeah.
Okay.
You are exponentially and asymptotically approaching zero every time you die.
So there's all these. Let's see here. Let's see if recharge. So I've got the recharge. So
Okay,
I
if
could
your health
recharge.
goes low.
I throw away. Why would I throw it away?
Presumably you only have so much room in your inventory. but
Yes.
I'm gonna grab another beer. Are you still good?
I'm good. I got plenty here. Let's see here. Go back to it. Ooh, new area of the map. I've been missing this one. Been in plain sight. Oh no, these guys look like bosses. They're
Oh, they're moving.
boy.
I'll keep an
Okay,
eye on your health,
yeah.
hopefully.
Yeah.
Disrespecting. That's my favorite comment of the night.
Take that, Benny.
When you throw brass knuckles instead of using them, they assume it's only going to take one shot.
I took care of those guys.
That's amazing. Oh, all right. Prediction. Record high DC current magnetic field. Greater than 30 Tesla or less than 30 Tesla?
Very smart. Greater than 30 Tesla. At the Maglab here in Tallahassee, we've got a 45 Tesla hybrid magnet that consists of a resistive magnet, and inside of it, another superconducting magnet. Adds up to 45 Tesla. Oh, go ahead.
So we may be dating ourselves by this joke, but yo, dog, I heard you like magnets. So we put a magnet inside a magnet to make a stronger magnet. Anyone? MTV, Pimp My Ride. Do you remember that show with
I do.
who was it? Was that Exhibit? I don't.
Good
But
times.
that's awesome.
Good times. So no, I
You
just
put
jumped in the
multiple
water.
magnets together, half your money gone. So 45 Tesla.
Yeah.
How do we conceptualize that?
Yeah, how do we conceptualize
I mean,
that?
what would we pick up with a 45 Tesla magnet?
Well, let me put it this way. So it's in a two-story area, and it's supported by these steel beam. Well, they're probably not steel. They're probably more of a non-magnetic, but high-strength beams, right? And they're held in with these giant bolts. And periodically, they have to retighten those bolts because when they ramp up the magnetic field, it moves things around. And they've had to put in new bracing, I think, over time to hold it up there. So this magnetic field is strong enough to bend and change, loosen, really high strength structural objects in a building. And in order to build, so a magnetic field, when it's changing, it exerts, it forces on things and tries to bend them and crush them and things like that. they would really like to build a 60 Tesla magnet like this, but in order to do it, my understanding is that they would really need to build a whole new building for it. Right? It would need to just have its own building that's custom built for it so that the magnet doesn't just tear the building down eventually.
So that was an issue with early NMRs. Like when those, if you're not familiar, an NMR is essentially an MRI for molecules, and like when chemistry departments started getting them, and they're a huge breakthrough. That's why organic synthetic chemistry can do what they do. But like, they weren't expecting the forces involved with those large fields, and so they were like pulling down roofs, like not collapsing them entirely, but enough strain that over time these things do damage. And when you get up to, and that's what is a standard MRI or an NMR now? It's probably maybe 2 Tesla with 600 megahertz, 800
Yep, that sounds
and
right.
so that's non-trivial, and this is 45 Tesla. That's intense. It's
amazing. Another fun thing to know about that is that when the Maglab came here, it came here from MIT, right, in the first place, and that was kind of a big deal. The way they got it here is they made a lot of promises, and one was that they would build something like a 45 Tesla magnet. And I think that the expectation was not that it would work and survive for this long, that it would wipe itself out eventually. And so it's really a testament to the engineers and the scientists who built it in the first place, like how good they were.
So when was that first built?
Let's see. So the Maglab got here in '94, and they definitely didn't have it right away, but it was the early 2000s.
Wow. It's been 20 years. That's crazy.
Yeah, it's way past its expected lifetime.
So what's the highest record now?
Well, DC it's 45, but pulsed field is more like 120, something like that.
So
well, actually that's non-destructive. Destructive magnets you can build can get well over 200 Tesla now, but they wipe themselves out. And in fact, for people in the audience, if you're interested, you might be able to find a YouTube video of one of them destroying themselves.
Destructive magnet.
Yeah.
That's awesome.
Yeah, look up pulsed field 200 Tesla or something like that, and you might see it. And it's really dramatic. I mean, when those things go off and wipe themselves out, it just obliterates it.
So the non-destructive, how long does that field last?
So that for the pulsed field?
Yeah.
Well, the field itself will be on for some milliseconds. And so, actually, sorry. This is an interesting thing to know. The Maglab actually has 3 sites. There's the one here in Tallahassee. There's one at UF in Gainesville. And there's one at Los Alamos. And they each have a different function. And the one at Los Alamos is all about the pulse field. And so because those magnetic fields are really short-lived, in order to make them useful, they also have to be experts at very short timescale measurements. That's kind of the business that they're in. It's not just making the big fields, but also specialized measurements that can take advantage of them. So these guys are kicking my butt.
Yeah, they are. Just running up, punching you in the face.
Take that! No! You guys suck.
Oh man. Huddle Puppy, that means meme's only 15 years old. Like 15 years. My freshman Gen Chem students are 18 years old.
They weren't even...
Like I'm looking at grad school applications of people born in 2000.
Yeah.
And I graduated high school in 2000.
I try not to think about that.
No, but it's one of those, like, I learned quickly, like, don't try to make cultural jokes in class. Because
they're not going to get it.
They're not going to get Simpsons jokes. Like, they might have 10 years ago when I started, but even now it's a very different, meme and political landscape. So, only 15 years old.
It's a little bit weird to be old.
Yeah.
But oh no! I jumped off the side of the building.
32 qubit. What is Simpsons? That's the thing. People know what the Simpsons are, but be able to quote, Simpsons, SMRT and
SMRT.
Bees are in the what now? And like, we grew up on this shit for 2 decades.
Absolutely.
I don't watch it anymore, but still. Reese's Pieces has a challenge. Bonus points if you know an exhibit album without Googling. Man, it's been a long time since I've thought about albums.
Well, so the funny thing that I'm seeing with my kids now, because my oldest is in middle school, is that there's these cultural things that now she knows everything about, and I don't know about it.
Mm-hmm.
She thinks I'm really dumb. Profoundly dumb.
I mean, it's tough. Like, you get glimpses of that, though. At least you're somewhat culturally relevant. I'm detached until my daughters are like, what, 10, 12 years old?
Yeah, but at least you know all the popular cartoons.
I do know. Bluey.
Bluey, I don't know anything about Bluey.
Bluey is actually pretty amazing.
Wow.
You should probably watch it. It's this really heartfelt, it's an Australian show. But like, it's entertaining for kids, but also it's just this heartfelt family where the parents are completely invested in like their kids' fantasies and play life, and it's
cool.
I strongly recommend it to anyone, even if you don't have kids.
Is it on Netflix or something?
It is on Disney Plus.
Oh, okay. We'll give it a try. My little guy might like it. He's 2.5, so
yeah,
maybe he'd be.
I mean, my 5-year-old likes Bluey, so there's a range demographic. But
my oldest used to like Jake and the Neverland Pirates.
I have no idea what that is. We've already lost that window.
It's like Peter Pan, kind of.
Yeah.
But now we talk to her about it, and she's like, "Don't talk to me about that."
Dad, I'm so grown up and mature.
Why would you talk to me about that?
Yeah, you're so lame.
And I am.
Lame a word?
True.
Do we use that anymore?
No. My 8-year-old told me that something was sus the other day. I know what that means.
Yeah, that's from what's the game?
Oh yeah, the what was it? The one where they kill each other and you have to try and figure out who's killing.
Yeah, that's where it's from.
Yeah, we played that.
It's
that
so
was
sad
fun.
I don't know this name. But that game lasted for like 2 months and it was huge, and everyone on Twitch was playing it, and then it just like disappeared.
It was fun, but it was only fun for a little while.
So someone put the name of that game in chat. It's Among Us, right?
Among Us. That's
Among
what it
Us is the game. There we go. I never played it, but it looked like fun.
Yeah, we were playing it at Christmas last year with the family.
My kids love Adventure Time. Yeah, Adventure Time. That's enough. I mean, but even that one's old right now. Is that one still new episodes?
No, that's done.
Yeah,
I'm pretty sure that's done. Yeah.
Anyway, we've gone down the, or the kids say us, Among Us. Among Us. Thank you, Reese's Pieces, keeping us culturally relevant. Speaking of relevance, we have no right to be talking about culturally relevant things because we are nerds and we don't.
That's right. We didn't know in the first place.
Yeah, exactly. We weren't up to date on things back in the day. So for now, we'll stick to the science. If anyone has science questions, we have about 45 minutes left. If you have questions for Ryan, Ryan's an expert in magnetism, exotic materials, topological materials, getting into quantum computing as well. So yeah, throw your questions in about quantum materials or whatever you might want to know. And we'll pop up some predictions sometime soon. But for now, I'm going to pop up one of my questions, or give you one of my questions. And this is one of my favorites because I've watched a lot of movies. My wife and I have been cord cutters for over 15 years now, which is kind of crazy. We watch a lot of movies. But the question is there a movie that gets your discipline or expertise or something related to your particular domain of expertise? Is there a movie that gets it right and one that gets it wrong?
This game is really satisfying. I'm really not doing anything but wandering around and beating these guys up. That's really good.
Yeah. So yeah, Brian, that question's for you. Is there?
Oh, it's for me.
Yeah, that's not a question for the audience. Or they could throw it in there too.
I got you. Well, let's see here. Not so many movies about condensed matter physics.
I mean, I'll give you an example, like Ocean's 11, where they use an EMP to block out all of Las Vegas.
Yeah.
That's a hell of a magnetic field necessary to do that.
That's true. Boy. Well, what was that movie where they had to go not blow up the asteroid, but to knock it off course? What the heck was that?
Armageddon.
Armageddon.
Yes.
A highly entertaining movie. I think really unrealistic.
What did they get wrong? What was intellectually offensive to you?
I mean, just the amount of energy you'd need to blow that thing off course, I think was pretty unrealistic. So, I mean,
And that's a good question. You can do that math.
You can do that math. You can, and I think, in fact, the government is actively doing that math.
Yeah, they need a contingency plan.
Yeah, but I think that what they've shown is that, for one thing, even if you can blow up one of those, big objects, they don't like really blast apart. They kind of break into a few loosely correlated pieces, but they just kind of keep going in the same direction.
I mean, that's an interesting question, though. So, like, if you catch them far enough away, even if you can move them, like...
Yeah, if you catch them far enough away, you'd be all right.
1 degree, you can change a lot with very little energy, right?
I
Like,
think
that's
that's
why
true.
that's the goal behind, like, solar sails, right?
Yeah.
Where you use photons to drive forward. So, I mean, there's ways you could do it. The answer is not with drilling into them and dropping a nuke inside.
Yeah. Yeah.
So CXZ has a suggestion. Knowledge is power in this game. The best power-ups are in the bookstores.
Oh. Well, here I am.
You only have $13.
That's good
We've been
advice.
playing this game for an hour.
What is a scandal rag? Well, I guess it's a scandalous magazine.
Oh yeah, that's
Okay.
like the National Enquirer of this game.
Well, I think probably Nuclear Spy would be something good to buy. Sounds useful. Yeah, sure, why not? I'll take that. Got the Nuclear Spy. No, that... Oh,
So I mean, back to the EMP, right? So there's catastrophic solar events that could wipe out electricity all over the Earth, right?
yeah.
And there's supposedly one of those happened in the 1800s. I
Yeah.
think I saw a Reddit like today. I learned post about that, but
Yeah,
it could
I've seen
literally
that too.
happen at any moment. I mean, how powerful are EMPs? Is that like a legitimate concern when you deconstructively explode a magnet or a superconductor? Do those let out pulses?
They must. I don't think that... I mean, I've actually been next to a pulse field magnet when it quenched. So, is this one of my questions?
No, I don't think so.
Okay, maybe it's a factoid. Okay, so the thing about pulsed field magnets is that the way they work is that it's kind of like an EMP, I guess. You're dumping a huge amount of electrical energy through a solenoid in a very short period of time. And that makes a very big magnetic field. But, it's going to put out a pulse too. In any case, they're made out of just special wire, that can conduct electricity really well. But sooner or later, they're going to break. I mean, sooner or later, they're going to break. And when they break, if some part of that solenoid gets open and it can't pass the current anymore, now it's got to dump all that energy somewhere else. And these things are normally submerged in liquid nitrogen to keep them nice and cool, and which lets the electricity pass more easily. But so when they open and they fail, they dump all of that energy in the form of heat, and they convert all of that liquid nitrogen to gas instantaneously. It's incredibly loud, and it creates this huge cloud of cold liquid nitrogen, it's not liquid anymore.
Yeah.
And it condenses, all of the moisture out of the air. So there's a huge cloud, like, it comes down. And it's a very violent and destructive event. So if you're in the vicinity, you notice it for sure. I think if you're a little ways away, it's trivial. So I think the number that I came up with, or I was reading about this prior to this, it's something like 11 sticks of dynamite going off all at once.
Jeez.
So that's a lot, but it gives you an idea of the scale of the energy. Like it's a lot, but it's not that much. I mean, it's
a relative thing.
Yeah, relatively speaking, it's really not a huge release of energy. It's relative. I mean, but it's not like setting off a nuclear, an EMP, over a city or something like that. That's a whole other scale of destructiveness
And power.
Yeah.
All right, we have 2 predictions left. We converted these guys.
What's that?
Keep going on this one.
Okay, let's do it. Nobel Prizes for superconductivity. How many Nobel Prizes for superconductivity? Greater than 3 or less than 3?
All right. We will give you guys 2 minutes as usual. Another one that's not easy to Google. All right, Nobel Prizes for superconductivity. Use your standard internet units. Put them in there right now. Was that the save code? That's how it
made it to some. Wow, I forgot about save codes. Look at that. That's a crazy
password. So the question is, how many Nobel Prizes have there been for superconductivity? Greater than 3 or less than 3? Well, find the trick question part of that one. No, there's no trick question. This one's pretty straightforward as well. But yeah, how many Nobel Prizes have there been for superconductivity? Keep in mind it was discovered in 1911. Question is, how many Nobel Prizes has it gotten people since then? Throw your guesses in there now. If you're not following, click the follow button, get your 300 standard internet units, spend them on gambling on science questions, because that's what we do on this channel. All right.
I've somehow trapped myself in an area that I don't know how to get out.
You can't get out of the menu?
This is pretty pathetic. I can do belongings, password.
Wait,
help.
CXZ, how do we get out of this? We're late in the night. We're a few beers in. We're getting beat by the menu in River City Ransom, ladies and gentlemen.
This is pathetic.
Somebody clip that. The highlight reels.
It might be time to switch to NARC.
Oh, man.
Maybe not quite yet.
We'll give you 5 more minutes.
Okay, if I can get out of the menu.
All right, Nobel Prizes for superconductivity. Is it greater than 3 or less than 3? Throw your guesses in there now. Click the predict button. You can either spend 10 or put your personal amounts or whatever amount you want. Might as well gamble some internet points. Greater than 3 or less than 3. The answer could be 0. We don't know. Oh, so no, there you go. Exit.
Exit.
Press start. Start doesn't do anything.
Ah, you got it.
All right, we're good.
There you go. That's the gaming experience in action.
Mediocre gameplay, expert level science, ladies and gentlemen. Comes to fruition on stream.
Oh no! Oh, these guys are killing me. How about this? All right, Doug.
So we got another standard question we ask, and I don't know if you'll have the best answer, because the best answer we've gotten is a shark attack, but what's the most expensive or dangerous mistake you've seen in lab?
Ooh, I've got a couple good ones.
All
okay.
right.
So in my line of work, it turns out that when you heat up elements by themselves, they do different things than when you heat them up with other elements, right? So maybe that kind of sounds like it makes sense.
I mean, yeah.
But sometimes you tend to forget that. So one thing that I did that was not very smart was once
you could have said, I knew a person.
I knew a person once. We use all sorts of different crucibles, basically containers for heating things to really high temperatures. So there was a crucible made out of tantalum, which is a great material for heating to really high temperatures. It doesn't melt till like 3,000 degrees C, doesn't react with a lot of stuff. So, okay, that's great. I made the mistake of not checking whether or not it reacted with nickel, and I put some nickel in the tantalum, and I started heating it up in an induction furnace, and at about 1100 degrees C, the whole thing melted down.
Oh, no.
Quite a mess.
Holy crap.
And I was just grateful that I didn't have any really dangerous elements in there.
Yeah. It didn't like vaporize osmium into the air or something crazy.
Exactly. Yeah. And it's a rookie mistake. It's the sort of thing that I should have known better, but I just wasn't thinking about it.
So that's dangerous and expensive. That oven is...
Yeah, that was toast.
$50,000 oven, something like that.
So the good thing about it was that actually it was in a custom built oven that I made, and it was I had a quartz tube that I had suspended between some other things. So the only thing that really got destroyed was the quartz tube.
Huh.
And
Well,
thankfully, so I really like to build crystal growth equipment from scratch, so that I can make mistakes and switch out parts, and it doesn't cost a whole lot. And that was one example where it turned out to not be really so bad. But in my lab, I've got a collection of broken and destroyed things that I call the Wall of Shame. And actually, I've contributed to the Wall of Shame quite significantly.
Yeah. So if you had to put a dollar amount on the most expensive mistake you've seen.
I think a bad mistake that I've seen made is a magnet quench that was unintentional. So superconducting magnets need to be immersed in liquid helium to keep them cold. So they're in the superconducting state, not the resistive state. And so if you don't fill that helium on a regular basis, that magnet may get out of the superconducting state, and then when you put a current on it, it'll heat up and destroy itself the way that any other metal would. I saw that happen once. That was not pretty.
That's on a NMR, or?
It was on something called a magnetic properties measurement system.
Oof. So those are at least 250,000.
Yeah, they're like 250, 300K. And at that time, it was more expensive, adjusted for inflation, because it was a newer type of instrument at that time.
So it's a $500,000 mistake.
I think so.
Oh man,
I did
brutal.
not do that, thankfully.
Yeah, I knew a guy.
But it was early on in my career, and I was just traumatized. Like, oh man.
No, rightfully so. That's devastating.
Another awful thing that I saw is that in labs like mine, we like to use hydrogen-oxygen torches to melt quartz, to seal materials in it, because it's a nice non-reactive thing that you can put under vacuum. And I once saw a quartz bench where someone had not turned off the gas bottle when they were done, and they walked away, and they set the torch on the line that brought the gas out, and it burned through it, and then then the flame burned the entire bottle of hydrogen, and it was bad.
Jeez.
The only thing that saved us on that one is that the working area for the quartz bench back in the good old days was surrounded by asbestos. So
Saved by asbestos. That's amazing.
But the cleanup was really a nightmare.
I believe it.
Yeah. Oh, and one more great thing that is just fun. It didn't really hurt anyone. But in the old days, people made pressure gauges out of with mercury,
Yeah.
And in one lab I was working in, we weren't using mercury anymore, but this lab had been there for, since the 50s.
Bottles of mercury laying around.
So in a cabinet in the back of the lab that had been blocked off, we didn't even know this cabinet was there. There was a giant glass cylinder where they had put all of their mercury waste for about 20 or 30 years. And this thing was full to the brim with mercury. There was no way you could move it.
Yeah.
And
mercury's heavy, if you guys don't know.
Super heavy. And then
like lead ball. Heavy. Yeah.
Actually, now that we're talking about it, I remember now that then it was part of a lab cleanup, and one graduate student thought that maybe he could take care of it to slide it out, and some of it got out.
Oh.
I don't think it all broke, but some got out.
Metallic mercury isn't that bad. It's like when it's vaporized or it's in the alkyl mercury form, but still, it's when you have that much of it, that much of anything that's even slightly toxic is just a lot. All right. Nobel Prize for superconductivity, greater than 3 or less than 3?
Greater than 3.
Which is crazy. Most major discoveries / materials get 1.
Yep.
Superconductivity gets... How many did it get?
I think it's 4 or 5. I wish I remembered the exact number. But I mean, it's like this. So remember we were talking earlier about whether or not theory leads or experiment leads, or is it collaborative? Well, superconductivity was an experimental result.
Speaking of which, we're at 10:30.
It's
time for NARC. Are you ready
time for NARC. Let's do it.
We're going to put your clock up.
All right.
As well as...
NARC time.
Who's excited? It's time for some NARC.
Yeah, look at those guys. That's how it was in the 80s.
That's how everything was in the 80s.
Everything right all the time. And that's why my parents wouldn't let me go to the big city.
That's true. Everyone was trying to give you free drugs. It was crazy.
It was crazy.
They just free. Drugs aren't expensive.
I remember that. So I grew up close to Sacramento, California, which is not like a very big city, really.
Yeah.
I remember there was a field trip in middle school where we were going to go to Sacramento, and there was a big deal about how we should not wear red or blue.
Bloods and Crips.
Yeah, because we might get shot.
Yeah. Yep.
And that was something that people were worried about.
I went to grad school in downtown Los Angeles, and it was a legitimate concern in that area.
Yeah.
But All right. So it turns out Ryan's actually played NARC before.
I know this game. I wouldn't say I'm good at it.
Good enough.
Gotta get the money.
You've played it before. Just say no license plate. Yes. Nope. This game was designed by Nancy Reagan. Made that up. That's not a real factoid. All right. So sorry. We went back to Nobel Prizes for superconductivity.
Oh yeah. So what I want to
theory got one.
Well, so experiment I think was first, and then it wasn't until superconductivity was discovered in 1911, and it took a long time to figure out how this was even possible. It wasn't until the 1950s when there was finally a theory for superconductivity that was really successful. And I'm sure that must have been one of the Nobel Prizes. Mm-hmm. And then, for a long time, there was an assumption that the only type of superconductor you could have is the phonon-based one, where the electrons pair so sad. As a result of...
so to shoot the dog,
yeah,
you have to squat shoot.
Oh yeah, you got squat shoot. Ah, you dumb dogs. Oh, we got to kill a lot of dogs in these games, though.
No, don't worry.
Really
they turn into little dogs and run away. It's only if you rocket them that it kills them.
Got it. It totally makes sense. This all adds up.
Yep.
Yeah, so people thought, okay, superconductivity, this is cool, but it's really only going to work at pretty low temperatures because of how this mechanism works, having to do with phonons and all that. Well, in the 1980s, there was a totally unexpected discovery that in some copper-based materials that we call cuprates, you could actually get much higher superconducting transition temperatures. And that gave the idea that actually, superconductivity might have a lot more possibility in it. Mm-hmm. And I'm sure there was a Nobel Prize in that, and no doubt I'm missing, one or two. But the point is that, this is a field that just keeps on giving us new.
Yeah, use the card right there. Yep, and then go through the door.
Got it. Wow, cool. So there's a lot of unexpected, incredible things that have been discovered, and I think there's probably still a lot that will be discovered.
I mean, 4 or 5 Nobel Prizes. That's pretty amazing.
It's pretty amazing. And I think, so remember we mentioned earlier about the hydrogen superconductors and the work that's being done on that now.
Somebody does it.
I think the people who are working in that area are exactly thinking of this,
This is my Nobel Prize.
Yeah.
Man, that's pretty intense.
Yeah, and if they really... Okay, so let me be a skeptic now. And remember, superconductors have 2 properties. They're perfect conductors, and they expel magnetic fields. And that magnetic field expulsion is called the Meissner Effect. It's pretty straightforward to measure a zero resistance, which is the thing that we always think about for superconductors. Measuring the Meissner Effect is something we can do, but actually for these ones that are at really high pressures, there's some pretty significant experimental challenges to actually be able to do that. Mm-hmm. So something that's going on right now is trying to figure out how to... Wow, look at this place. This is science, man. This is what my lab looks like.
A lot of wet chemistry. I'll give you that.
A lot of wet. Look at that. I mean, what are they making in there? Well, it's probably
blue.
Drugs. It's
red.
Drugs.
They're making red.
Yeah. This is the prequel to the Matrix, actually. Oh, gotta use the blue card.
Oh, you gotta shoot these guys to get a blue card.
Ah, you guys.
There you go.
There we go.
Nice.
That's such a...
USB Mark has an important question. Hey, just out of curiosity, if I tape a massive magnet to my body for a huge amount of time, will I be magnetic?
Definitely.
Like some sort of Magneto. I mean, joke about that, but they've suspended frogs in magnetic fields, right? Like, yeah. What's required? What field is required for that?
So, at the Maglab in the early days when they were doing a lot of different crazy things, they actually did suspend a frog.
That was at the Maglab?
That was at the Maglab. And
Like the MIT one or the FSU one?
The FSU one.
Wow, I didn't know that was FSU.
Yeah,
I've seen videos of this.
They got in trouble because it's working with vertebrate animals.
Oh, and they didn't have the IRB approval. Wow.
Yeah. So we don't do that anymore. But
I mean, you could write it for approval.
You could, and I mean, wouldn't that be neat to see? But and it doesn't hurt the frog. So
as far as we know.
As far as we
know that ahead of time.
We didn't follow the frog afterwards. But
intense.
I think some tens of Tesla, and you're there. You know.
Yeah.
Yep.
I mean, they haven't tried it on a human yet, but theoretically, 100
yes.
Tesla, you could do it.
You could do it.
No question.
You could do it. Who wants to volunteer?
IRB approval.
Yeah. I think that probably the main reason that they don't want to do that is a public affairs type of thing.
Yeah.
You know.
I mean, so it's essentially inducing a temporary field within the body, right? And it
That's
repels
right.
it, and that's
yeah.
So
it's a diamagnetic response. You put a magnetic field on electrons that are sort of the core electrons, and they just oppose that. They move and they don't get away from their nucleus, but they do oppose it, and then you can levitate stuff that way.
You should stop squatting. Yeah, there you go. It's much faster if you're not squatting.
Do I get in the car?
Yep.
Oh yeah.
But you're probably gonna blow it up. But heads up. So jump, tap B.
Oh wow. What a game.
I mean, this game has a lot of this game has a lot of terrible things, but the one thing I'll give them is they turned 2 buttons into 4 actions.
It's amazing.
Right? So
it's really good.
Tap A is rockets, hold A is bullets, tap B is jump, hold B is quad.
Cool.
Yeah. So they did some things right, but yeah, there's a lot of terrible things too.
Oh, do we have to fight this guy hand to hand?
I mean, so that's the question by USB Mark does bring up an important thing, because we talked about movies and what gets your discipline right. Magneto obviously not getting things right, but one of my favorite. There was a book that was released. It's got to be over 20 years ago now, called The Physics of Superheroes.
I did read that.
You've seen that book, right? And so it's awesome. They used superhero stories to teach physics to students, like how fast would someone have to jump, how much energy would Flash have to eat, so on and so forth.
Yeah.
But the one thing they did in that I thought was really interesting is what rule of physics or law would have to be suspended for this to be true. And so for a human to be a Magneto, what rules would have to be abandoned? What laws would they have to break?
Huh. Oh, that's really interesting. Well, I mean, okay, if a human was going to be a Magneto, they'd have to generate some sort of magnetic field.
Yeah, but not continuous. It'd have to be controlled pulse.
Yeah.
You're going that way, jump.
Jump.
B. There you go.
Dang, this is quite a game.
So they'd have to do a pulsed field.
Yeah.
Control directionality.
They would have to get electrons to move in a very specific way inside of their body.
Yep.
I have no idea how you would do
Or
that.
be filled with magnetic nuclei.
Yes.
Some kind. Like instead of hemoglobin with iron, it's like neodymium or something.
Neodymium in them, yeah.
What would it take?
Yeah, I don't think that being a refugee from World War II would quite cut it.
Yeah. But USB Mark, we're trying to give you answers here. We're trying to let you turn into
That's a
Magneto.
very interesting question. I mean,
Well, that's one of the things I really like about really good sci-fi writers is they don't completely abandon all rules.
Yeah.
You just need to abandon one and have it be cohesive from there, and you're okay.
that's true.
So,
I was recently reading a series of books.
plot.
I'm going to drive you crazy.
You are. The clock is running. You're at 9 minutes and 7 seconds.
But look at this cute little dog.
Yeah, I just want you to beat it. This is the victory of the night right here. We're gonna
I got you. I got
beat
you.
NARC.
All right, let's see if we can do it.
No, we'll do it either way. I'll stay up till midnight if that's what it takes. So Magneto's superpower, and that's what was fun about it, is like the Flash's superpower wasn't running fast. It was converting energy to speed.
Yeah.
That was the skill set. Or if you're going to be like someone that creates ice, you're like somehow, controlling enthalpy really, really quickly.
Sure.
So go bottom, and then if you go up a little bit,
Oh yeah.
I'm going to coach you through this.
Oh yeah.
I'm gonna slow down. There'll be bombs here, and then a wall. We go down,
This guy's a really
go
good
up.
driver.
and there's random bombs up
Oh
here.
no, not this guy.
And then,
No.
oh,
Run, Narc, run.
oof, Cuddle Puppy. Fun one. This is another mainstay of Ask a Scientist Gaming. If there were no moral, ethical, or legal boundaries to your work, what is your favorite Star Wars movie? I didn't read the end of that question. Cuddle Puppy, way to go. Threw a curveball in at the end. What's your favorite Star Wars movie?
I liked, what was that one? The one where it's one of the newer ones.
Rogue One?
Rogue One.
That is the correct answer.
I
as
like
far
that
as I'm
one so
concerned.
much.
Like,
Yeah.
that was the actual horrors of war. Like, people died at
That
the
was
end
cool.
to accomplish things.
Yeah.
Spoilers. Sorry. So go ahead and jump. I think if you stay on the bottom, you're safe most of the way here.
High speed.
Anyway, Cuddle Puppy, screw you for looping me into that one. I'm going to correct this question and say, if there were no moral, ethical, or legal boundaries, and you have an unlimited budget, what experiments would you do?
Oh, let me take this exit. What experiments would I do? I don't think that in my line of work there's a whole lot of ethical or moral
You
questions.
could float a human.
Could float a human. That would be pretty fun.
Yeah. You see how big of a field a human can withstand. Because at some point, you're like, hemoglobin, iron, you would start
At some point, it should do
biasing
something
it,
to you.
right?
Yeah.
Like it would
Oh, good
go
Lord,
a direction.
Look at this.
Yeah, clowns. Drug clowns with knives.
I mean, this game is like, it's real. This is really
based
what was
on a
going
true
on
story.
in the 80s. It's pretty,
Yeah, we grew up in the
tough
80s.
time. War on drugs. That was important. Wow.
It was made out to be a lot more important. Did you do DARE, the DARE program?
yeah.
Oh
Yeah,
my
yeah,
God.
yeah. Yeah,
It's been definitively established that actually makes drug use worse.
Does it?
Yeah.
God.
Yep. But who listens to evidence?
Nobody. It's pointless. I mean, why would you?
Exactly.
Oh God! What is this little car? Is this a Shiner or something? Or Shriner?
A little go-kart. But yeah, what would you had unlimited budget, we'll say. 'Cause the moral ones, yeah.
Yeah. I mean,
so I'll give you some context to this question. So we have a developmental psychologist that would purposely produce twins and separate them at birth. We have a demographer who would strap ankle bracelets on every person in a city and send a hurricane their way,
oh my
just
God.
to track mobility.
Oh my God.
So think big.
Wow.
Go that way.
I mean, if I could really do anything, I would really love to be able to work like more with the
Yep. Go through the next door, but don't go all the way up.
Okay. More with elements like plutonium and americium, and I mean they're really cool. We just don't know all that much about them.
Yeah.
They're super
So go
dangerous.
through that, but don't hold up. No,
Oh,
that's not a good design.
could you imagine having to play this? Well, you probably could play it without messing up at this point. Come on, guys. We got no business here.
No, it's definitely
There we
beatable. You just have to know the patterns. So now you're silver carding there.
Oh, wow. So I gotcha. Okay.
Yep.
Bye, clowns.
So working with the rare and expensive elements, unlimited budget,
I mean,
you could dedicate a particle accelerator to making grams of this shit.
That would
if
be
you
cool.
wanted to,
Yeah,
right?
that would be cool.
You could build your own to produce it in-house,
Yeah.
separate it.
Yeah, that would be pretty great. I mean, that's not a very exciting answer, but you'd certainly learn a lot of new and weird things, I think. Social people can do a lot more interesting things.
I mean, they're sexier answers, but even, I mean, you could build a bigger magnet right now.
You
right?
could
With an
build a
unlimited
bigger
budget,
magnet.
right? You
Absolutely.
could do pulsed one. You could do. This is the only one you go left on, actually.
Definitely build a bigger magnet. I mean, like to make a furnace that goes to ridiculously high temperatures. That would be cool.
You could drill to the center of the Earth and
could
cook
drill
it
to the
directly
center
there.
of the Earth, and why not?
We're talking unlimited budget here. Don't let your
Yeah, I mean,
Let your creativity go wild.
I really enjoy heating things to
go.
extremely high
Green card.
temperatures. So if I could, really, I like melting stuff.
I mean, you could do high temperature, high pressure.
Yeah, that'd be cool.
External field, like.
Yeah.
I mean, those are really expensive experiments.
They're super expensive. Bust them or blast them. I think we know the answer to that.
If you've busted anyone, I think it's by accident.
That's right.
Those are pot plants for you to seize as evidence. Yes, they are.
Oh no, the clown's getting me.
For all the court cases that will happen after this, because all this is legal and above board. This game is terrible, and I apologize, but it is a mainstay of our channel.
This is a fantastic game.
And we have several emotes dedicated to this particular game.
The Reagans would be proud.
If you melt a magnet, is it liquid magnetic?
That's a good question. So there is such a thing as a liquid magnet in a sense. There's like ferrofluids and stuff like that.
Mm-hmm.
But in a solid state system, the net magnetic moment that you get has to do with all those spins sort of being in a position and then all pointing in the same direction. So having a liquid magnet is kind of an unusual thing, but I don't think that it's impossible. And I think a lot of people would love to have something like that. Maybe it would be useful in some sorts of like magnetic bearings, things like that. There's probably all sorts of incredible engineering applications for something like that, but I think it's not very common. No doubt people would like to work on stuff like that.
All right, we're at 10:50. We're approaching the end of NARC-ish. We'll see how it goes when he plays the big boss man coming up. It's Mr. Big, actually. But anyway, our guest tonight, Ryan Baumbach, is an expert in magnetism, exotic materials. If you guys have any questions, we have about 10 minutes to answer those questions. Also, everyone, if you have suggestions about who we should raid, we should do that. This time I won't stop streaming. In fact, we'll raid before I stop streaming. I screwed it up a couple weeks ago. But throw your suggestions in chat. But we also have one more prediction, so it is time to do it right now. Everyone that has internet points, you should bet on this one. This is a fun question for me as a
this
chemist.
is a good one.
I'm very curious how this. I don't know if I would have gotten this right if I didn't get told the answer immediately. So I look forward to everyone guessing on this. If you have standard internet units, bet them on this question right now. The question is, what % of elements are a semiconduct? And so the periodic table, superconduct. So the periodic table is composed of 118 elements that we know of right now. What percentage of those will superconduct? And so if you made them into magnets and you could apply an electric current to them, what % of that would superconduct? Is it greater than 25% or less than 25%? Keep in mind, this is all 118 elements. It's hydrogen, helium, lithium, barium, boron, all the way down to, californium, einsteinium, all the crazy heavy things. What % will superconduct? Greater than 25%, less than 25%? Oh, that's fun. CX Xander has a suggestion of rating F. Coughlin, who is performing manipulated Final Fantasy runs, attempting a world record speed run. Ooh, that's fun.
Cool.
Cuddle Puppy. I saw a documentary called Avatar, and there's a new element called unobtainium.
Absolutely.
Get with the times, people. Well, that's one of the 119 we're gonna make acceptable for this question. Throw your guesses in there. No one is guessing right now. What is your guess in elements? I think people game the system and they wait to see what other people bet.
Yeah, that makes sense.
But anyway, is it less than 25% of the periodic table or greater than 25%? So this includes all the, standard organic, hydrogen, helium, oxygen, nitrogen, transition metals, lanthanides, actinides. This is everything in the periodic table. What % of those elements will superconduct? Throw your guesses in now. If you're not following, click follow, get your points, bet them big on this question. I'm really curious on the outcome on this. This is a fun one. This was an accidental question, actually.
Cool.
Documentary called Avatar.
I like that. Have you watched that since it came out?
No, I haven't.
I haven't either.
I saw it in theaters, and it was when we were in LA, and it had really nice 3D goggles, like the really nice polarized goggles,
Yeah.
and it was amazing.
Yeah.
And like looking back on that now, that was the most information dense movie to have ever existed. Because not only did you have standard XY on the screen, but it was XY plus a Z.
Yeah.
All right,
Yeah,
so
yeah.
you got a blow up wheelchair guy with rockets.
Really?
Yes.
Good God.
There you go. And any inchworms.
This is truly a work of art.
Cuddle Puppy. No one has watched it since it came out.
I mean, I think that might be true. I remember thinking that it was really good.
Yeah.
You know, when I saw it,
It was
but
beautiful.
yeah.
So my major contribution to speedrunning this game is that if you despawn him off the left side of the screen, he does an inchworm, and it saves you 28 seconds.
Oh, got it. Awesome.
So that's me applying scientific method to solving NARC. Cuddle Puppy. It was a tech demo movie. It really was. Like it was beautiful though. Like
Look at that. He's got a picture of himself
say,
on the wall.
say what you will about the story and the Dances with Wolves and Pocahontas scenario, but like it was pretty. It was, yeah, it had interesting visuals.
Yeah.
The sequel, we'll see how that's received.
We'll see.
Since 3D has completely fallen out of favor. Oh, there you go. That's the third.
Got him. That's right, Mr. Big.
Fern Gully, the tech demo. Fern Gully 8.0. Yes. Wasn't a new idea. All right, we got one suggestion of who to raid. I'll look up. I mean, retro gaming is our demographic, so.
Beware.
Dances with Smurfs.
Whoa, what is this?
That is Mr. Big, ladies and
Oh,
gentlemen. If you
Mr.
haven't seen him
Big, come
before,
on,
this
man.
is the pinnacle of gaming.
This is not appropriate. Look at this.
So you got to rocket him in the hat while jumping. My tip is to go to the top of the screen because he can't hit you with his tongue. Don't you remember the 80s?
I remember the 80s. This seems very realistic. Very much on.
You kind of walk to school and this guy comes along and wants
Totally.
you to take heroin.
Yeah. Maybe he already got our hero to take heroin, you know? I mean, look at this.
All right. What percent of elements superconduct?
So this is a very interesting answer. I mean, naturally speaking, if you don't do anything to them, surprisingly large number. Roughly half. If you pressurize those guys, sooner or later, almost all of them become superconductors.
The answer is greater than 25%.
Right.
So even without pressure, it's almost half.
Yeah.
If you apply significant amounts of pressure, it will be greater than. So several people actually got a 34-to-1 payout on that question.
Wow.
Congratulations, ladies
Nice
and gentlemen.
job.
If you said greater than 25%, that's really counterintuitive. Because you think about the periodic table and you're like iron, right? And
Yeah.
neodymium and some of those standard things. But in this case,
Whoa.
man, if you put them under the right conditions, under the right pressure and temperature.
Yeah.
By the way, congrats on getting the rocket so far. So this is bullets. The vertebrae is bullets. So get to one side, turn back and shoot at them. It depends where you're positioned on the screen and when you turn back and when you shoot your bullets.
Wow.
It is really stupid. This is the jankest boss ever. It's all those radioactive elements, bro. No, we said half the periodic table already. But yeah.
Well, the thing I think is really neat about that is that, it's not like, elements. We've been familiar with elements as, a species for a long time, and yet no one knew anything about this, for the longest time. And then it turns out that half of them do this type of behavior.
Yeah, no, that's true. Like we understood like phase changes for centuries, right? Liquid, solid, gas. And then all of a sudden superconductivity exists. And now we know 110 years later that almost all of them do it. There you
Pretty
go.
amazing.
You did it.
Yay!
So now,
Victory!
almost.
Uh-oh.
There's one more board. This is our favorite level of the entire game. As if it couldn't get any better with Mr. Big. GG's, congratulations. We beat a game tonight.
Gold safeguard.
Yep. Are you ready?
I'm ready.
This is civil forfeiture, the level. This is all you do this entire level.
Wow.
This is it.
I mean, do you think that the people who made this game, who programmed it, are like still around and
I hope
available to provide their perspective on this?
I hope so.
That would be really something to hear about. Wow. Boy.
2452, and that's without help on the boss. I think you are the best NARC player that's been a guest on this stream.
Wow.
Someone can correct me on that, but I
feel really good about that.
I think Ryan has done it. He's achieved something no one else has.
When I get to my lab tomorrow, I'm going to tell my students that. Listen, guys.
It counts for something. Do you want to guess what the world record in this is, though?
What, like 5 minutes?
No, 9 minutes and 24 seconds.
Wow.
Yep.
Wow. Ooh, I get into my initials.
Yep, and if you put in ass, it doubles your score.
This is not really my initials, but I'll...
Cuddle Puppy, this isn't a good example of civil forfeiture because there's actually probable cause for assuming the money was gained from criminal activities. That's fair. No, we've ridiculed this for at least a year now on this stream, and you brought up a good point. Civil forfeiture of the level. All right.
Wow.
It is 10:59.
Wow. Perfect. Can you believe it? Like, perfect time.
No,
Incredible.
We nailed it tonight.
Wow. Wow.
All right, ladies and gentlemen, we used all our predictions. We beat NARC. Other games were a struggle, but that's fine. It's kind of the nature of the beast.
Maybe Battletoads next time.
Yeah, and I think we're gonna raid. Who are we gonna raid? F. Coughlin. So stick around for a raid after we bail here. Yeah, you didn't even need the cheat codes for Mr. Big. You just did it, which is pretty impressive. So
it must be
kudos.
all that experience I had from when I was like 7 or 8,
day.
you know?
If you made it to Mr. Big back in the day, I'm super impressed.
No way. There's no way.
But anyway, ladies and gentlemen, thank you for joining us again for another Ask a Scientist Gaming. This is the last one of the year. We're going to holiday break. I might stream if I get Halo Infinite just for fun. But other than that, we're going to hold off. I think January 5th is going to be our next stream. That's going to be Robert Lazenby, who's an electroanalytical chemist who measures biomolecules with electrochemistry, which is moving electrons to measure signal. It's how a breathalyzer works effectively. So, January 5th will be our next stream. Until then, Ryan, any parting words for the audience?
It's been a pleasure. Hope we can do it again sometime.
Yeah.
And thanks for the invite. This was really great.
No, it's awesome. You got to relive some old games and play NARC and beat NARC. So, Ryan, it's been a pleasure. I learned a lot, actually. I love these streams because I learned a lot about stuff that I don't know.
Very cool. I'll be tuning in next time.
Sounds good. So, January 5th, if you guys are interested. Until then, again, thank you for coming by. The audience is what makes this possible. However crazy or awesome the questions are, it really brings us down a rabbit hole that we're happy to discuss. So stick around. We're going to do a raid quick. But until January 5th, we'll see you guys and enjoy your holiday break and Happy New Year.